Thousands of years ago, under the same night sky we look upon today, our ancestors traced shapes in the stars and told stories that shaped civilizations. They saw gods in the constellations, dragons in the darkness, and cosmic battles playing out above them, stories that felt like truth long before telescopes could prove it. What's astonishing isn't just how wrong they were, but how often they were right. The same questions that haunted ancient mythmakers: where did the universe come from? What are stars made of? Are we alone? Still drive scientists today. This is the magic of cosmic storytelling, where the line between myth and science blurs into something far more profound: humanity's unshakable urge to make sense of the infinite. Think about the Greek legend of Orion, the mighty hunter placed among the stars as a constellation. To ancient storytellers, his belt was a mark of heroism. To modern astronomers, it's a cosmic nursery where new stars are born. Or take the Norse myth of the world tree Yggdrasil, its branches stretching across realms, a poetic mirror to the vast cosmic web that connects galaxies. These aren't just coincidences, they're proof that myth and science share the same roots, a longing to explain the unexplainable. And here's the thrilling part: we're still writing that story. Every discovery, from black holes to dark matter, adds a new chapter to the epic we began telling around campfires millennia ago. So what if I told you that the oldest stories ever told hold clues to the universe's greatest mysteries? That the same awe that made our ancestors name the planets after gods now fuels billion-dollar telescopes and quantum experiments. This video is a journey through time and space, where we'll unravel how ancient wisdom and cutting-edge science converge in ways that will leave you breathless. We'll meet the stargazers who turned mythology into mathematics, and the researchers who found truth hidden in tales. By the end, you'll see the night sky not just as a scientific frontier, but as humanity's oldest, most enduring storybook, one we're still learning to read. Ready to decode the universe's greatest story? Let's begin. Long before we had star charts or quantum physics, humanity's first astronomers were storytellers. Picture this: a Babylonian priest tracing the path of Venus across the night sky, not just as a flickering light, but as the goddess Ishtar descending to the underworld. Or a Mayan scribe recording an eclipse, certain it was the gods whispering warnings through the darkness. These weren't mere fantasies, they were revolutionary acts of pattern recognition, attempts to impose order on chaos using the only tools they had: observation and narrative. Take the constellation Orion, known to cultures from ancient Egypt to the Aboriginal Australians. The Greeks saw a hunter with a sword and belt, while the Lakota people of North America recognized it as the hand of a great chief pointing the way. What's remarkable isn't just the diversity of these tales, but their shared foundation: precise celestial observations. The three stars of Orion's belt aligned so perfectly that cultures separated by oceans and millennia couldn't ignore their symmetry. This wasn't just storytelling, it was proto-science, a way to encode astronomical knowledge in myths that could be passed down for generations. And then there's the Dogon people of Mali, whose oral traditions described Sirius, the brightest star in our sky, as having an invisible companion centuries before telescopes confirmed Sirius B, a dense white dwarf star. How did they know? Some call it coincidence, others argue for lost wisdom, but the truth may be simpler. Humanity has always been better at science than we realize. When Polynesian navigators used star paths to cross thousands of miles of open ocean, or when the builders of Stonehenge aligned its stones with solstices, they weren't just creating myths. They were conducting experiments, recording data, and building theories just without the jargon we use today. what ties these threads together is something profound. The human brain is wired to seek stories, even in the stars. Neuroscience shows we process patterns as narratives. It's why we see faces in clouds or constellations in random star fields. Our ancestors didn't have the luxury of calling something unknown. They had to explain it, to weave it into their understanding of the world. And in doing so, they stumbled upon truths that would take millennia for science to confirm. The line between myth and astronomy was never as clear as we think, because both, at their core, begin with the same irresistible question: what does it all mean? Creation stories from across the globe share an eerie similarity, not just with each other, but with the most cutting-edge science of our time. Take the Hindu Rig Veda, written over 3,000 years ago, which describes a universe born from a cosmic egg, bursting forth in an explosion of heat and light. Sound familiar? It's a poetic mirror of the Big Bang, complete with the same sequence: a singularity, an unfathomable expansion, and the birth of matter from pure energy. Even more astonishing is the Maori concept of Tikor, the void that existed before creation, a description that aligns uncannily with modern cosmology's idea of quantum fluctuations in the primordial emptiness before time began. Then there's the ancient Egyptian myth of the Benben stone, the primordial mound that rose from chaotic waters to become the first land. Swap waters for quantum foam and land for matter, and you've got a startling metaphor for how particles condensed from the seething energy of the early universe. These parallels aren't just poetic accidents, they reveal something profound about how the human mind grapples with the unimaginable. Whether through myth or mathematics, we're all trying to answer the same question: how can something come from nothing? Consider the Aboriginal Australian story of the Dreamtime, where ancestral spirits sang the world into existence. At first glance, it seems purely symbolic, until you learn that modern string theory suggests the universe's fundamental particles are vibrations, tiny cosmic notes resonating through higher dimensions. Or the Norse tale of the fire giant Surtur, whose flames will one day consume the world, a chillingly accurate metaphor for the heat death of the universe, when entropy reaches its maximum and all energy disperses into cold, endless stillness. What's truly humbling is realizing these ancient storytellers weren't just making things up. They were observing, deducing, and encoding truths about reality in the only language they had. When the Maya depicted the cosmos as a ceaseless cycle of destruction and rebirth, they anticipated the cyclical universe model now debated by physicists. When the Dogon spoke of a small, heavy star orbiting Sirius, they described centuries ahead of telescopes, what we now know as a white dwarf. These myths weren't primitive guesses. They were the first drafts of humanity's greatest story, written in starlight and intuition. So why do these patterns emerge across cultures separated by continents and millennia? Perhaps because the universe leaves clues in plain sight. The night sky, the changing seasons, the very laws of physics, they all whisper the same fundamental truths. And whether you're a shaman chanting by firelight or a physicist crunching equations in a lab, you're part of the same timeless pursuit to crack the code of existence. The real magic happens when we realize that science didn't replace these ancient stories, it's just giving us new words to tell them. If there's one thing that unites ancient myths and modern science, it's the unshakable belief that the universe runs by rules. The Egyptians called it Mat, the sacred principle of balance and order that held chaos at bay. Hindus named it Dharma, the cosmic law that governs everything from the cycles of rebirth to the motion of planets. These weren't just abstract ideas, they were humanity's first attempts to codify the patterns they saw in nature. And here's the breathtaking part. Today's physicists are still chasing that same certainty, only now we call them the laws of thermodynamics or the constants of quantum mechanics. Consider gravity, a force so fundamental that every culture crafted stories to explain it. The Greeks spoke of Atlas holding up the heavens, while Norse myths described four dwarves named North, South, East, and West propping up the sky. These weren't mere fantasies, they were intuitive grasps at a truth science would later confirm. The universe doesn't tolerate disorder. Just as math demanded harmony, Einstein's equations reveal a cosmos where spacetime bends to keep everything in its rightful place. Even the ancient concept of karma, the idea that every action has an equal reaction, finds its echo in Newton's third law. For every force, there's an opposing force of the same magnitude. The real magic lies in how these myths anticipated the precision of physical laws. Take the Hindu belief in cyclical time, where universes are born, destroyed, and reborn in endless loops. It's a striking parallel to modern theories of cosmic inflation, where our universe may be one bubble in an infinite multiverse, or the Babylonian Enuma Elish, where the god Marduk slays chaos by fixing the stars in their paths, a poetic precursor to Kepler's laws of planetary motion. These stories weren't wrong, they were frameworks, placeholders for truths waiting to be measured. What's truly humbling is realizing that the constants governing our universe, the speed of light, the strength of gravity, are as unchanging as any divine decree. The ancient Maya calculated Venus's orbit with an error margin smaller than 1 day per 500 years, all without telescopes. Polynesian navigators memorized star risings and settings with the precision of an astronomer's almanac. Their myths weren't just tales, they were user manuals for a lawful cosmos, written in the language of the sacred. So when we talk about the laws of physics, we're continuing a conversation that began millennia ago. Whether carved on temple walls or scribbled in a physicist's notebook, the message is the same. The universe speaks in patterns, and we've been listening all along. The rules have gotten more precise, but the awe remains unchanged because every equation is just another way of asking, what holds it all together? And that question, it turns out, is older than the stars. There's something hauntingly beautiful about how the oldest stories in human history seem to whisper secrets we're only now beginning to understand. Take the Norse concept of weird, those invisible threads woven by the Norns that determined the fate of gods and mortals alike. To ancient skalds, these were the unseen forces guiding every life, but today, cosmologists describe something eerily similar: dark matter, the invisible scaffolding of the universe. It's as if our ancestors sensed the presence of something they couldn't see, something pulling strings behind the cosmic curtain. Consider how cultures worldwide imagined spirits or deities inhabiting empty spaces. The Aboriginal Australians spoke of Mimi spirits living in rock formations, intangible yet shaping the land. The ancient Greeks believed the air itself was alive with daemons, invisible beings influencing human affairs. Now fast forward to modern astronomy, where we've mapped galaxies rotating so fast they should tear themselves apart unless some unseen mass holds them together. That's dark matter, making up 27% of the universe's mass energy content. It's gravity weaving galaxies into a vast cosmic web. The parallels are uncanny. Just as myths described unseen hands guiding reality, science reveals an invisible architecture holding the universe in place. What's even more striking is how these stories anticipated dark matter's behavior. Hindu texts describe the serpent Ananta floating endlessly in the void, its coils supporting the world, a poetic mirror to how dark matter's gravitational filaments cradle galaxies. Or the Polynesian belief in mana, an invisible energy permeating all things, much like how dark matter's influence stretches across light years. These weren't just flights of fancy, they were intuitive leaps toward truths we're still unraveling. When a Navajo elder speaks of the holy wind that knows all things, it resonates with how dark matter's distribution maps the universe's large-scale structure, a hidden blueprint written in gravity. So why does this matter? Because it reveals something profound about human curiosity. Faced with the unknown, we've always reached for explanations, first through stories, now through equations. The Maori tale of Rangi and Papa, the Sky Father and Earth Mother locked in an embrace until their children forced them apart, isn't so different from how dark energy pushes the universe to expand. Both are attempts to explain why things hold together or fly apart. Perhaps the most humbling thought is this: if our ancestors could glimpse today's discoveries, they might nod in recognition. The language has changed, but the wonder remains. We've traded spirits for subatomic particles, fate's threads for quantum fields, yet the essential mystery endures. What invisible hands shape our cosmos, and how many more of their whispers are still waiting to be heard? From the moment humans first looked up at the night sky, we've been dreaming of crossing impossible distances, not just across oceans or mountains, but into the stars themselves. Ancient myths are filled with heroes who dared this very thing. Gilgamesh seeking immortality beyond the world's edge, Icarus flying too close to the sun, the Polynesian navigator Maui snaring the sun to slow its passage. These weren't just adventures, they were blueprints for a longing coded into our DNA. Fast forward to July 20th, 1969, when Neil Armstrong took that giant leap for mankind onto the lunar surface. The mission's name, Apollo, after the Greek god who rode his chariot across the sky each day. The parallels aren't poetic coincidence, they're proof that space exploration is the latest chapter in humanity's oldest epic, the hero's journey. Think about the structure of these stories, whether it's Odysseus sailing uncharted waters or the Navajo hero twins ascending to the heavens. Mythic quests follow a pattern, a call to adventure, trials that test the hero's limits, and a return with hard-won wisdom. Now listen to the Apollo astronauts describing their missions, the heart-stopping moment of liftoff, the eerie silence of lunar orbit, the awe of seeing Earth as a fragile blue marble against the void. Their words could have been lifted straight from an ancient saga. Even the dangers align. Icarus's wax wings melting mirrors the razor-thin margins for error in spaceflight, where one miscalculation means catastrophe. The stakes haven't changed, only the scale has. What's truly remarkable is how these archetypes shape our real-world endeavors. The Voyager probes, carrying golden records of human greetings and music into interstellar space, echo the Babylonian myth of Etana, who flew heavenward to retrieve the plant of birth. SpaceX's Starship takes its name from the universal metaphor for journeying beyond, whether it's Polynesian canoes navigating by star paths or the USS Enterprise, boldly going where no one has gone before. Even the setbacks follow mythic logic. When the Challenger shuttle tragically failed in 1986, the public grief mirrored mourners keening for fallen heroes like Phaethon, who crashed the Sun chariot. These aren't just stories, they're psychological roadmaps helping us process the enormity of venturing into the cosmos. Consider how deeply these narratives influence our vision of the future. Elon Musk talks about making humanity a multiplanetary species, a phrase that wouldn't sound out of place in the Epic of Gilgamesh. NASA Artemis program, aiming to return humans to the moon, draws its name from Apollo's twin sister, goddess of the hunt and wilderness. The symbolism is deliberate. If Apollo represented our first fumbling steps into space, Artemis embodies our deliberate stride toward staying. And just as ancient heroes carried talismans for protection, astronauts bring cultural touchstones, from the Apollo crews leaving moon rocks as offerings at temples to the UAE's Hope probe carrying a digital copy of the Quran to Mars. This interplay between myth and mission reveals something profound. We don't just explore space with rockets and equations, but with stories that give meaning to the void. When China's Chang lunar rover takes its name from a moon goddess who drank the elixir of immortality, or when India's Chandrayaan moon craft in Sanskrit evokes Vedic hymns to celestial chariots, it's more than branding. It's a declaration that spaceflight isn't just physics, it's the continuation of a dialogue we've been having with the universe for millennia. The same urge that made Polynesians memorize star paths now drives engineers to calculate gravitational slingshots. The wonder that painted gods among the stars now builds telescopes to search them for life. Perhaps this is why space exploration captures our imagination like nothing else. It's not just about discovering new worlds, but rediscovering ourselves, the part that still gazes upward and whispers, "What if?" The heroes have traded winged sandals for pressure suits, but the journey remains the same, into the unknown, armed with nothing but courage and curiosity. And when the first humans set foot on Mars, you can bet they'll be walking in the footsteps of giants, both the kind who stride across rocket launch pads and those who once strode across the starlit dreams of our ancestors. Every culture has its doomsday, a moment when the sky falls, the earth shakes, or the seas rise to swallow the world. The Norse called it Ragnarök, a twilight of gods where fire and ice clashed in the final battle. The Maya inscribed prophecies of a great flood that would cleanse the fifth sun. Even the Bible's tale of Noah reads like an ancient survival manual, warning of divine reckoning through water. What's chilling isn't just the consistency of these stories, but how often they align with real cosmic threats science now confirms. These myths weren't just metaphors, they were memories etched into legend by survivors of catastrophes we're only beginning to understand. Take the Tunguska event of 1908, when a meteoroid exploded over Siberia with the force of 12 megatons, leveling 800 square miles of forest. Witnesses described a column of blue light splitting the sky, followed by a shockwave that knocked people off their feet hundreds of miles away. To scientists, it was a stark reminder of Earth's vulnerability. But to anyone familiar with Norse myths, it sounded eerily like Thor's hammer striking down giants, a celestial battle made real. The parallels don't stop there. The Hopi speak of a fiery sky knife that once fell to Earth, while Aboriginal Australian stories describe a time when the sun itself changed course after a cosmic collision. These aren't coincidences, they're cultural echoes of disasters that shaped human history. Dig deeper, and the evidence becomes undeniable. The Younger Dryas impact hypothesis suggests a comet may have struck North America around 12,900 years ago, triggering wildfires, climate shifts, and extinctions, events mirrored in flood myths from every inhabited continent. Even Plato's account of Atlantis sinking beneath the waves finds a possible counterpart in the Mediterranean Storiga slide, a colossal underwater landslide that sent tsunamis crashing into ancient coastal settlements. What if these stories weren't just allegories but ancestral PTSD, survival wisdom passed down as cautionary tales? The sky can fall, the earth can break. Be ready, modern astronomy confirms just how precarious our existence is. The Chicxulub crater in Mexico, buried for 66 million years, marks where an asteroid wiped out the dinosaurs, a reminder that extinction lurks in the cosmic dark. Today, NASA tracks over 30,000 near-Earth objects, some with orbits that could one day intersect ours. Supervolcanoes like Yellowstone simmer beneath national parks, capable of plunging the planet into volcanic winter. Even our sun, long worshipped as a life-giver, will eventually expand into a red giant, vaporizing Earth in 5 billion years. The ancients may not have known the physics, but their stories captured the existential truth. The universe is both creator and destroyer. What's remarkable is how these myths often held practical advice. The Maori story of Tohaki climbing the sky to retrieve baskets of knowledge included warnings about falling stars, a possible reference to meteor showers. The Finnish epic Kalevala describes Väinämöinen diverting a fireball with a magical song, a poetic nod to deflection strategies now studied by planetary defense agencies. Even the biblical ark, sealed with pitch, mirrors ancient and modern methods of waterproofing against floods. These narratives weren't just doomsaying, they were survival guides wrapped in symbolism. So why does this matter now? Because the line between myth and mitigation is thinner than we think. When NASA, a DART mission, successfully nudged an asteroid off course in 2022, it wasn't just a technological triumph. It was humanity's first step toward rewriting an old story. No longer passive victims of celestial whims, we're becoming the heroes of our own cosmic saga, armed with telescopes instead of talismans. But the wisdom remains the same. Look up, prepare, and never assume the sky is silent. After all, the universe has ended worlds before. The question is whether we'll heed the warnings etched in starlight and stone. From the Egyptian Duat's labyrinthine underworld to the shimmering halls of Valhalla, humanity's visions of the afterlife share an uncanny thread. They're not endings but gateways. These ancient conceptions of other realms weren't just about morality or comfort. They hinted at a truth modern physics now grapples with, that existence might be far vaster than a single life or even a single universe. Take the Aboriginal dream time where ancestors exist in an eternal, everyone, simultaneously past, present, and future. It's a concept that mirrors physicist Hugh Everett's many worlds interpretation, where every quantum decision spawns parallel realities. Both suggest a cosmos where death is merely one door in an infinite corridor of possibilities. Consider how precisely these myths map to cutting-edge theories. The Norse described Yggdrasil, the world tree whose branches hold 9 distinct realms, some home to gods, others to giants or the dead. Compare that to string theory's 11 dimensions, where alternate universes might float like leaves on a cosmic tree, each with different physical laws. Or the Hindu concept of lokas, layered planes of existence from the subterranean Patala to the celestial Satyaloka, echoing modern hypotheses about brain worlds, parallel universes separated by higher dimensional membranes. Even the ancient Tibetan Bardo Thodol, or Book of the Dead, describes a 49-day journey through transitional states, unsettlingly similar to quantum decoherence, where particles exist in multiple states until observation collapses them into one. The most provocative parallel lies in the idea of quantum immortality, a thought experiment suggesting consciousness might persist in universes where the observer survives, no matter how improbable. It's a scientific twist on the Buddhist wheel of rebirth, where the self cycles through existences until enlightenment. Both propose that awareness isn't confined to a single timeline. When the ancient Greeks spoke of the Elysian fields reserved for heroes, or the Maori of Tirurenga Wariua where spirits leap into the afterlife, they might have been intuiting what physicists now call the multiverse, a tapestry of realities where every outcome unfolds somewhere. What's truly breathtaking is how these ideas emerge independently across cultures. The Dogon's celestial afterlife, reached via a path of the dead mirroring the Milky Way, aligns with astronomers' models of cosmic filaments connecting galaxy clusters. The Maya's Xibalba, a watery underworld guarded by gods who test souls with illusions, finds an eerie counterpart in simulation theory's proposal that our universe could be an advanced civilization's holographic construct. Even the Christian resurrection of the body parallels quantum information theories conjecture that consciousness might one day be reconstructed from cosmic data. This isn't just poetic coincidence. It reveals how deeply human cognition is wired to perceive reality's layered nature. Neuroscience shows our brains construct models of possible futures, essentially mental multiverses, to navigate uncertainty. Ancient mythmakers externalized this process as gods, spirits, and afterlife realms. Today, we use equations, but the underlying impulse remains to grasp that existence is bigger, stranger, and more interconnected than it seems. Whether through shamanic trances or particle colliders, we've always sensed there's more to the story. So the next time you hear an old tale about crossing into the land of the dead, remember, it might be closer to scientific truth than we ever imagined. After all, if the multiverse is real, then somewhere out there, every myth is literally true. And that's perhaps the most astonishing convergence of all. That science hasn't debunked these ancient stories, but given them new life in dimensions we're only beginning to measure. Stories of celestial visitors are as old as human civilization itself, gods descending in chariots of fire, winged messengers bearing wisdom, or amphibious beings emerging from the heavens to teach agriculture and astronomy. The Dogon people of Mali still recount the Namo ancestral spirits who arrived from Sirius in a vessel filled with water, bringing knowledge of the stars. The ancient Sumerians etched the Anunnaki into clay tablets, describing them as those who from heaven to earth came. Even the Bible's Ezekiel witnessed a wheel within a wheel descending with beings like burnished bronze. For millennia, these accounts were dismissed as myth or religious allegory. But what if they were something else entirely? Early attempts to document encounters with beings beyond our world, not as fantasy, but as fractured memories of something real. Modern science is beginning to take these stories seriously, not as literal truth, but as cultural artifacts that might hold clues to humanity's deepest question: are we alone? SETI, the search for extraterrestrial intelligence, scans the cosmos for radio signals, while astrobiologists hunt for microbial life in Martian soil or Europa's icy oceans. The tools have changed, but the quest remains eerily similar. When the Dogon described Sirius B, a star invisible to the naked eye, centuries before telescopes confirmed its existence, it raises eyebrows. Or when Sanskrit texts detail Vimanas, flying machines with propulsion systems that sound unnervingly like anti-gravity engines. Coincidence, perhaps? But the consistency across cultures separated by oceans and epochs suggests something more. A shared human instinct that we've always been part of a larger cosmic conversation. Consider the Aboriginal Australian Wandjina, sky beings who painted their likenesses on cave walls with halos around their heads, strikingly similar to modern depictions of astronauts in helmets. Or the Tully papyrus from ancient Egypt, which describes circles of fire hovering over Pharaoh's court, their breath smelling of rotten fish. Even the medieval Nuremberg Chronicle documents a mass sighting of cylinders in the sky in 1561, sparking panic. These accounts, once relegated to folklore, now inform serious scientific frameworks like the ancient astronaut hypothesis, which asks, could contact have happened far earlier than we think? Not in the form of little green men, but as misinterpreted encounters with advanced civilizations. The real turning point came with the discovery of extremophiles organisms thriving in Earth's most hostile environments, from boiling hydrothermal vents to radioactive waste. If life can persist here under such conditions, why not in the methane lakes of Titan or the subsurface oceans of Enceladus? Suddenly, the Hindu devas, said to reside in celestial realms, not of this earth, don't seem so far-fetched. NASA James Webb Telescope now analyzes exoplanet atmospheres for biosignatures, gases like oxygen or methane that might hint at alien biology. It's a high-tech echo of the Maya watching Venus for omens, or the Babylonians tracking Jupiter's movements as messages from the gods. What's fascinating is how these myths often encode scientific principles. The Nomos watery vessel parallels theories about panspermia, the idea that life could hitchhike across space on comets. The Hopi legend of the blue star Katchina, foretelling a time when the heavens would shake, aligns with concerns about asteroid impacts. Even the biblical notion of fallen angels sharing forbidden knowledge mirrors contemporary debates about the risks of advanced alien contact. These stories weren't just entertainment, they were cautionary tales, survival guides, and perhaps even early attempts at xenobiology. So where does this leave us? Somewhere between skepticism and wonder. The truth may be less about ancient aliens and more about the human mind's uncanny ability to intuit truths before it can prove them. Whether through myth or radio telescopes, we've always strained to hear whispers in the cosmic dark, to know if the universe is talking back. And as our probes land on distant moons and our signals pierce the interstellar void, we're not just searching for life. We're fulfilling an ancient prophecy written in the stars, that one day we'd reach out to the very beings our ancestors once called gods. Hidden in the walls of Egypt's Osirian temple, carved into the pillars of India's Hoysala architecture, and painted across Tibetan sand mandalas, you'll find the same shapes repeating circles within circles, interlocking triangles, spirals that seem to breathe. These aren't just decorations, they're blueprints. Ancient cultures worldwide revered geometric patterns as sacred because they glimpsed something profound. The universe speaks in geometry. And here's the astonishing part: modern telescopes and microscopes confirm they were right. The same spirals that adorn Celtic knots govern how galaxies spin. The hexagonal honeycombs praised by Pythagoras appear in Saturn's North Pole. Even the double helix of Danae echoes the caduceus, the serpent-twisted staff carried by Hermes, god of knowledge. This isn't coincidence, it's a cosmic syntax written into the fabric of reality. Take the flower of life, a pattern of overlapping circles found from Chinese temples to Phoenician textiles. To alchemists, it represented the seed of creation. To quantum physicists, it mirrors the Voronoi diagram, the way bubbles pack together in foam, or cells divide in an embryo. Then there's the Sri Yantra, a Hindu diagram of 9 interlocking triangles that generate a staggering 400 smaller triangles through precise mathematical recursion. It's a visual echo of fractal geometry, where simple rules create infinite complexity, just like the branching of trees or the jagged coastlines of continents. Even the humble circle, symbol of eternity in everything from Aztec calendars to Zen Insigh paintings, describes planetary orbits and electron shells with perfect accuracy. These shapes weren't chosen at random. They're observations, ancient humanity recognizing the fingerprints of creation. Nowhere is this more striking than with the Fibonacci sequence, where each number is the sum of the 2 before it, 0, 1, 1, 2, 3, 5, 8, and so on. This pattern appears in Sanskrit poetry meters centuries before Fibonacci introduced it to Europe. It shapes the spiral arms of hurricanes and the arrangement of sunflower seeds exactly as described in the Hindu Vedas' golden womb of creation. When you see a nautilus shell spiral matching a galaxy's whirlpool arms, or the branching of bronchi in lungs mirroring the tributaries of a river, you're witnessing what mystics called, as above, so below, the principle that cosmic patterns repeat at every scale. Modern science calls it scale invariance, but the insight is millennia old. Perhaps most mind-bending is how these geometric obsessions anticipated discoveries like the cosmic microwave background, the afterglow of the Big Bang. Its temperature fluctuations form patterns eerily similar to the tree of life in Kabbalah, with its 10 interconnected spheres. Or consider the dodecahedron, a 12-sided shaped plateau linked to the ether composing the heavens. In 2003, astronomers found the universe itself may be shaped like a dodecahedron, where traveling far enough in one direction loops you back to your starting point. The ancients didn't have particle accelerators, but through intuition and observation, they mapped the universe's hidden architecture. What does this mean for us today? That the line between sacred art and scientific diagram was always blurrier than we thought. When Navajo sand painters recreate the 4 cardinal directions with precise angles, they're encoding celestial mechanics. When Islamic architects tile mosques with infinite star patterns, they're illustrating the non-repeating order of quasicrystals, materials only discovered in 1984. These traditions weren't just spiritual exercises, they were humanity's first attempts to chart the mathematical heartbeat of existence. And every time science unlocks a new layer of reality, from the fractal branching of neurons to the hexagonal storms on Jupiter, we find our ancestors were there first, tracing the shapes in stone and story. The cosmos whispers in geometry, and we've been listening all along. The ancient Hindus measured time in Mahayuga's vast cycles, spanning millions of years where universes rose and fell like breaths. The Aztecs carved their famous sunstone, a wheel of 5 world ages, each destroyed by cataclysm before renewal. Even the Greek phoenix, consumed by flames only to rise anew, carries this universal truth. Time isn't a straight line but a spiral. And here's what's breathtaking: modern cosmology keeps finding evidence they were onto something profound. From the pulse of pulsars to the potential rebirth of the cosmos itself, science reveals a universe that may truly move in eternal circles. Consider the most obvious cycles, the ones our ancestors tracked with stone circles and star charts. The Earth's 23.5-degree tilt gives us seasons, a rhythm so reliable that Neolithic farmers built Göbekli Tepe 12,000 years ago to mark its turning. The moon's phases dictated calendars from Babylon to the Maya, who calculated lunar cycles with near-perfect accuracy. But dig deeper, and the patterns grow more astonishing. Take the precession of the equinoxes. Earth's slow wobble completes a full cycle every 26,000 years, a celestial clock the ancient Egyptians encoded in pyramid alignments. They called it the Great Year, a concept mirrored in Hindu astronomy's description of the Sun orbiting the galactic center every 256 million years. These weren't just myths, they were precise observations of cosmic mechanics passed down as stories. Now zoom out to the grandest scales. The Big Bang Theory once suggested a linear universe, exploding from a single point and fading into heat death. But newer models propose something eerily familiar to those old myths: a cyclical cosmos. The Big Bounce hypothesis suggests our universe could be one in an endless series, expanding from a prior collapse before contracting again, a modern echo of the Hindu concept of Brahma's days and nights, where universes dissolve and reform. Even black holes, those ultimate devourers, might seed new universes through their singularities, as physicist Lee Smolin theorized. It's as if the Phoenix myth was a metaphor waiting for astrophysics to catch up. The most poetic evidence comes from the cosmic microwave background, the afterglow of creation itself. Its temperature fluctuations form patterns that some physicists interpret as bruises from a previous universe colliding with ours, like tree rings recording cosmic seasons. The Maya, who predicted solar eclipses centuries in advance, spoke of the fifth sun, believing 4 worlds had been destroyed before ours. Could their legends preserve ancestral memories of earlier cosmic cycles? It's a tantalizing thought, especially when quantum physics suggests time itself may be an illusion, that past, present, and future coexist in a block universe, making cycles inevitable. What's truly humbling is how these ancient models anticipated modern chaos theory. The Norse myth of Ragnarök, where the world ends in fire and ice only to be reborn, mirrors the cyclical nature of complex systems, from ice ages to stellar life cycles. Even the Buddhist wheel of samsara, with its endless rounds of birth and death, finds a parallel in thermodynamic cycles where energy constantly transforms but never disappears. The universe, it seems, is less a clock winding down than a dancer spinning through infinite variations on the same steps. So the next time you watch leaves fall or hear the tide roll in, remember, you're witnessing the same rhythms that inspired civilizations to see time as a circle. Whether through myth or mathematics, humanity has always sensed that the cosmos breathes in cycles, and with each discovery, from oscillating universe theories to quantum gravity, we're learning just how right the ancients were. The universe may not have a reset button, but it certainly knows how to repeat the chorus. Stretching its roots into the underworld and branches through the heavens, the world tree appears in nearly every ancient tradition, not as decoration but as architecture. The Norse called it Yggdrasil, an ash tree binding 9 realms together with its trunk. Hindus revered the Ashvattha, its roots in the stars and branches cradling the sun. The Maya envisioned Wakachan, a towering Siba piercing through layers of existence. These weren't just fanciful images, they were blueprints for a truth science would later confirm. The universe is woven together by invisible threads, a cosmic tapestry where everything is connected. And when astronomers first mapped the large-scale structure of the universe in the late 20th century, they found something astonishing: a sprawling, filamentary network of galaxies mirroring those ancient arboreal visions down to the smallest detail. Zoom out far enough and the universe reveals its skeleton. Galaxies clustered along shimmering filaments of dark matter, intersecting at dense nodes like knots in a grand celestial net. This is the cosmic web, and it behaves uncannily like those mythic trees. Just as Yggdrasil's roots drew nourishment from the well of wisdom, these filaments funnel gas into galaxies, feeding star formation. The Ashvattha's description of roots above, branches below, aligns with how gravity sculpts the web-pulling matter along invisible lines of force that stretch across billions of light years. Even the Mayan belief that Wakachan's roots reached into the watery underworld finds eerie resonance in modern simulations, showing how cosmic filaments channel ionized gas between galaxy clusters. What's truly breathtaking is how precisely these myths anticipated the universe's structure. The Norse described an eagle perched atop Yggdrasil, flapping its wings to stir the winds of the worlds, a poetic parallel to how supermassive black holes at galaxy centers eject energy along cosmic filaments, shaping their growth. Siberian shamans spoke of climbing the world tree to journey between realms, mirroring how galaxy clusters form at the intersections of web-like filaments, acting as portals to deeper cosmic layers. Even the ancient Egyptian Djed pillar, symbolizing stability and connection, resembles the spine-like filaments that stabilize the universe's architecture against the relentless pull of dark energy. Science now quantifies what intuition once sketched. The cosmic web's filaments account for nearly 60% of the universe's normal matter, yet they're so diffuse they remained invisible until X-ray telescopes caught their faint glow. Similarly, dark matter, the unseen roots of the cosmic tree, holds the web together through gravity we can't see but know is there. It's as if the ancients sensed this hidden scaffolding, describing it through metaphor because they lacked the language of astrophysics. When the Lakota spoke of the sacred hoop connecting all life, or the Celtic Druids revered oak trees as conduits of energy, they were mapping a truth written in gravity and plasma. Perhaps the most profound lesson lies in how both myths and science use trees to explain connectivity. Just as a single leaf is nourished by roots it will never see, galaxies billions of light years apart move in sync, tugged by the same cosmic currents. The next time you see a tree's branches fractaling against the sky, remember, you're looking at the universe's favorite pattern, repeating from the veins of a leaf to the tendrils of the cosmic web. The myths got it right. We're all dangling from the same infinite branches, drinking from the same starlit roots, and that's no metaphor, it's the structure of reality itself. From the shape-shifting Loki of Norse sagas to the mischievous coyote of Native American lore, trickster gods have always lurked at the edges of mythology, agents of chaos who twist rules, break boundaries, and remind us that order is never absolute. These figures weren't just entertaining villains, they embodied a truth about reality that modern physics would later quantify. The universe thrives on uncertainty. Just as Loki's pranks upended the careful plans of the Aesir gods, quantum mechanics reveals a subatomic world where particles defy expectations, existing in multiple states until observed. The parallels aren't poetic license, they're proof that humanity has always sensed the cosmic prankster hiding in nature's laws. Take Heisenberg's uncertainty principle, which states you can't precisely measure both a particle's position and momentum simultaneously. The more you pin down one, the more the other slips away, a behavior that would feel familiar to anyone who's watched Coyote's schemes backfire in Navajo stories. Or consider quantum superposition, where particles like electrons exist in all possible states at once until measured, collapsing into a single outcome. It's the scientific version of Anansi, the spider from West African tales, who famously could be in 6 places at once while weaving his webs of deception. Even Schrödinger's infamous cat, simultaneously alive and dead in its box, echoes the trickster's favorite game, keeping reality unresolved, dangling between possibilities. What's striking is how these myths anticipated the emotional impact of quantum weirdness. The Greek god Hermes, patron of boundaries and thieves, stole Apollo's cattle on the day he was born, only to charm his way out of punishment by inventing the lyre. It's a metaphor for how quantum particles cheat classical physics, tunneling through barriers they shouldn't cross or entangling across distances instantaneously. Similarly, the Polynesian trickster Maui slowed the sun's journey across the sky, bending time itself, a folkloric hint at Einstein's relativity, where time stretches and warps under gravity's influence. These stories didn't just entertain, they acclimated us to a universe where the rules are more flexible than they appear. The real magic lies in how both trickster tales and quantum physics expose our craving for certainty as an illusion. The Aztec god Tezcatlipoca, whose name means smoking mirror, embodied deceptive appearances, showing reflections that obscured truth, much like how quantum fields fluctuate in a vacuum, particles blinking in and out of existence like mirages. Indigenous Australian stories of the Wallugalu brothers describe dreamtime paths that shift when walked, mirroring the probabilistic paths particles take in Richard Feynman's quantum electrodynamics. Even the Hindu god Krishna, who playfully confused his devotees with paradoxical teachings, seems to channel the spirit of wave-particle duality, where light refuses to be neatly categorized. Perhaps this is why both physicists and shamans speak of reality as participatory, a dance between observer and observed. The trickster reminds us that chaos isn't the enemy of order, but its partner, weaving unpredictability into the fabric of existence. When electrons defy causality or dark energy accelerates the universe's expansion in ways we can't predict, we're witnessing the cosmic Loki at work. The ancients knew what science now confirms: the universe loves a good joke, and the punchline is always that we understand far less than we think. The image is hauntingly precise: a cosmic egg floating in the void, its shell cracking to release light, matter, and time itself. The Rig Veda, written over 3,000 years ago, calls it Hiranyagarbha, the golden womb from which all creation emerges. Chinese mythology speaks of Pangu, a giant born from this primordial egg who separates yin from yang with his axe, forming earth and sky. Even the Orphic mysteries of ancient Greece describe Phanes, the first god, hatching from a silver egg to set the cosmos spinning. What's astonishing isn't just the consistency of these stories across continents, but how closely they mirror modern cosmology's description of the Big Bang, a singularity infinitely dense, infinitely hot, exploding into the universe we know. Science describes the pre-Big Bang state as a point where all matter, energy, and even the laws of physics collapse into oneness. Time and space don't exist yet, there's only potential. Now listen to the Hindu Shatapatha Brahmana. In the beginning, there was nothing but the great egg, unbroken, undifferentiated, containing within it all things yet to be. Parallels are uncanny. The Chinese Hundan myth describes chaos as an egg without features, no up or down, no light or dark, until a sudden rupture creates duality. It's as if these ancient cultures intuited the concept of quantum fluctuations, where symmetry breaks and particles emerge from perfect uniformity. Even the details align. The Finnish Kalevala describes the cosmic egg splitting to form the heavens' upper shell and Earth lower shell, a poetic match for how the early universe's rapid inflation stretched space-time into the fabric we see today. The Egyptian god Atum, self-created from the waters of Nun, mirrors how quantum foam might spontaneously generate universes from nothingness. And when the Orphic eggs have become celestial spheres, it recalls the cosmic microwave background's echo, the afterglow of creation still resonating in every direction. These myths didn't just guess, they grasped the essence of cosmic birth through metaphor. The real magic lies in how these stories grapple with the paradox of beginnings. Science admits we can't see before the Big Bang. Time itself may not have existed. Myths solve this riddle symbolically. The egg is both container and contained, a closed loop needing no before. The Hindu Brahmanas state the egg was not made but always there, echoing physicists like Stephen Hawking, who proposed the universe has no boundary in imaginary time. Even the cracks in these cosmic eggs find scientific counterparts in phase transitions, the moments when the early universe cooled enough for forces like gravity and electromagnetism to freeze out from their unified state, like yolk solidifying into structure. What's humbling is realizing these myths weren't primitive science, they were something deeper. When a Zhuangzi text from 4th century BC China says, "The 10,000 things are born from the egg of chaos," it's not explaining mechanics but capturing awe. The same awe that grips physicists staring at equations describing singularity. Both are saying, here is the moment where logic fails, where poetry takes over. The cosmic egg isn't just a metaphor, it's humanity's way of holding the unholdable, of picturing the unpicturable. And in that shared act of wonder, myth and science become two halves of the same shell, waiting to hatch new understanding. Ancient myths are filled with heroes and gods who dared to descend into the underworld, a realm of shadows where the normal rules of life and light no longer apply. The Sumerian goddess Inanna stripped herself of power as she passed through the 7 gates of Urkala. each step taking her deeper into a place where even gods feared to tread. Orpheus ventured into Hades to retrieve Eurydice, only to lose her again when he broke the one rule: don't look back. These stories share something chillingly familiar with modern astrophysics' most enigmatic phenomenon, black holes. Both describe a point of no return, a boundary beyond which the known laws of existence twist into something unrecognizable. The event horizon of a black hole isn't just a scientific concept. It's the modern incarnation of those mythic gates where gravity becomes so strong that not even light can escape. And just as the underworld changed those who entered it, black holes warp space-time itself into impossible shapes. Consider the eerie parallels. The Greek Hades was said to be encircled by the river Styx, a dark current that severed the living from the dead, much like the accretion disk of superheated plasma swirling around a black hole's maw, marking the last visible trace of matter before it's lost forever. The Egyptian Duat, the perilous underworld traversed by Ra's solar bark each night, was guarded by demons who tested souls with riddles and traps. It's an uncanny mirror to the tidal forces near a singularity, where the gravitational pull is so uneven it would stretch a human body into a strand of atoms, a literal trial by destruction. Even the Mayan Xibalba, the place of fright, with its labyrinthine caves and deceptive lords, resembles the chaotic paths of particles caught in a black hole's ergosphere, where space-time itself is dragged into violent rotation. What's most striking isn't just the shared imagery, but the emotional weight these stories carry. When Dante wrote of the abyss in his Inferno, with its descending circles of torment, he captured the same dread that grips physicists confronting the information paradox, the idea that matter swallowed by a black hole might be lost forever, erasing the universe's quantum history. The Norse Helheim, a cold, mist-shrouded realm for those who didn't die in battle, finds a counterpart in Hawking radiation, the faint glow predicted to seep from black holes as they slowly evaporate into nothingness. Both myths and equations grapple with the same existential question: what happens to what's consumed by the dark? Perhaps the most profound connection lies in transformation. Myths often portray the underworld not just as a place of death, but of rebirth. Inanna was resurrected after 3 days in Urkala, forever changed by her ordeal. Similarly, black holes might not be endpoints but gateways, theoretical wormholes bridging distant parts of the cosmos, or even other universes. The Hindu goddess Kali, dancing on the edge of destruction with a necklace of skulls, embodies the duality of creation and annihilation that defines black holes, which can shred stars while also seeding new galaxies through their jets of energy. Even the Aboriginal Dreamtime speaks of the Wajil, a serpentine spirit that carved waterways as it moved beneath the earth, echoing how black holes might sculpt the cosmic web through their gravitational influence. These stories suggest something extraordinary, that humanity has always sensed the existence of cosmic voids, long before telescopes revealed them. When the Babylonians described the underworld as a house of dust where souls wore feathers like birds, perhaps foreshadowing how time slows to a standstill at the event horizon, freezing fallers in place like spectral echoes. Or when the Tibetan bardo Thodol instructs the dead to avoid the dark pit of terror, a warning that feels prophetic alongside the lethal spaghettification near singularities. The ancients didn't have the math to describe relativity, but their myths mapped the emotional terrain of the unknowable. So the next time you hear about a black hole's gravitational pull, picture Orpheus at the threshold of Hades, lyre in hand, staring into the dark. The science may be new, but the story is ancient, a tale of boundaries crossed, of forces beyond comprehension, and of the unshakable human urge to name the abyss. Whether through poetry or physics, we're still trying to answer the same question: what waits in the dark, and will it let us return? Across cultures and continents, serpents slither through creation myths not as villains, but as architects, coiling around the axis of existence, shedding their skin to symbolize rebirth and whispering secrets of life's cyclical nature. The Norse Jörmungandr, the world serpent so vast it encircles the earth with its tail in its mouth, embodies the endless loop of destruction and renewal. The Aboriginal rainbow snake wins through dreamtime stories, carving rivers with its body and spilling life into the land with every undulation. Even the Hindu Ananta, the infinite serpent who floats in the cosmic ocean cradling Vishnu, represents the unbroken thread of time. What's astonishing isn't just the universality of these serpent symbols, but how uncannily they mirror the very shape of life's blueprint, the double helix of DNA. It's as if humanity's oldest myths encoded the structure of our biology millennia before microscopes revealed it. Consider the visual parallels: DNA's twisted ladder, with its sugar-phosphate backbones and rungs of nitrogenous bases, coils like two serpents entwined in an eternal dance. The caduceus, the staff carried by Hermes, entwined with two serpents, was an ancient symbol of healing long before we understood DNA's role in cellular repair. The Mesoamerican feathered serpent Quetzalcoatl, often depicted as a plumed helix, brought knowledge and medicine to humanity, much like how DNA transmits genetic wisdom across generations. Even the Ouroboros, the serpent eating its own tail found in Egyptian and alchemical traditions, mirrors the circular chromosomes in our cells, where telomeres wear down and renew in a biological echo of eternal return. These aren't just artistic coincidences, they are glimpses of an intuitive truth about life's architecture. Dive deeper, and the connections grow more profound. The rainbow snake's association with water in Aboriginal lore parallels how DNA's structure relies on hydrogen bonds, the same forces that give water its life-giving properties. Jörmungandr's venom, said to kill even gods during Ragnarök, finds a dark counterpart in mutations where tiny chemical changes in DNA can unravel entire organisms. The serpent's shedding of skin mirrors the process of transcription, where DNA unwinds and replicates itself, leaving behind the old to create the new. Even the biblical serpent in Eden, offering forbidden knowledge, resonates with the double-edged power of genetic engineering today, the ability to rewrite life's code carrying both promise and peril. What's truly breathtaking is how these myths anticipated DNA's functional poetry. The Mayan god Kukulkan, depicted as a feathered serpent descending the steps of El Castillo pyramid during equinoxes, embodies the idea of descent with modification. The way genetic information flows downward through lineages, subtly changing with each generation. The Chinese dragon, a serpentine creature controlling rains and rivers, reflects how epigenetic factors can turn on or off genes like celestial faucets, directing the flow of biological processes. Even the Norse Nidhögg, a serpent gnawing at Yggdrasil's roots, mirrors how telomerase enzymes nibble at chromosome ends during cell division, linking decay and renewal at the molecular level. This convergence of myth and molecule reveals something extraordinary, that humanity's storytellers may have sensed the shape of life's essence long before science confirmed it. When Australian elders speak of the rainbow snake singing the world into existence, they're not far from the language of biophysicists who describe DNA's vibrations as a literal music of life. The serpent's sinuous form, recurring across cultures as a symbol of both chaos and creation, turns out to be the perfect metaphor for the molecule that balances stability and mutation, order and evolution. Perhaps that's why these stories endure, because coiled within them is a truth as old as life itself. That existence isn't a straight line, but a spiral twisting toward infinity. High above the Arctic, a single star holds perfectly still while the entire night sky wheels around it. Polaris, the North Star, our planet's celestial anchor. For millennia, cultures from the Inuit to the ancient Greeks oriented themselves by this fixed point, calling it everything from the nail of the heavens to the axis of the world. But this wasn't just navigation, it was cosmic storytelling at its most profound. From Hindu Mount Meru piercing the sky to the Norse Yggdrasil's roots gripping the underworld, humanity has always envisioned a central pillar around which creation turns. And here's the astonishing truth. Science now reveals these mythic axes weren't just metaphors. They were intuitions of real cosmic architecture, the spinning poles of planets, the magnetic heart of galaxies, and the invisible scaffolding that structures the universe itself. Take Mount Meru, described in Sanskrit texts as a golden mountain, so vast its roots plunge deeper than its peak rises, connecting Earth to the heavens. Modern astronomy paints a strikingly similar picture. At the center of our Milky Way lies Sagittarius A, a supermassive black hole whose gravity orchestrates the dance of billions of stars. Just as Meru's summit touches the realm of gods, Sagittarius A's event horizon marks a boundary where physics as we know it collapses, a true axis of cosmic mystery. The Maya saw this same center in their sacred ceiba tree, its branches cradling the heart of sky, while Polynesian navigators steered by the black hole of Tipunga, the celestial anchor they said held the stars from drifting. These parallels aren't poetic license, they're evidence of humanity's uncanny ability to sense cosmic order long before telescopes confirmed it. What's even more remarkable is how these myths anticipated the dynamism of celestial poles. The ancient Egyptians aligned pyramids with Thuban, a star that served as their North Pole 5,000 years ago before Earth's wobbling axis shifted Polaris into place. Similarly, Hindu texts describe Mount Meru as surrounded by rotating continents, mirroring our solar system's spiral movement around the galactic center. The Dogon people of Mali went further, describing the Milky Way as a spinning spiral of stars anchored by an invisible eye, a near-perfect match for modern images of our barred spiral galaxy, its stars swirling around a dense core. These stories didn't just guess, they observed, encoded, and passed down truths about the universe's fundamental geometry. The real magic lies in how these axes function as cosmic compasses. Just as the North Star guided sailors through treacherous seas, the galactic center provides a reference point for mapping the universe's expansion. The Bighorn Medicine Wheel in Wyoming, a Native American stone alignment, points not only to Polaris but to solstice sunrises, echoing how astrophysicists use quasars as fixed points to measure cosmic distances. Even the Aboriginal concept of the sky rope, a luminous thread connecting Earth to the Emu in the sky constellation, finds its scientific counterpart in the magnetic field lines that channel solar winds toward our poles, creating auroras. Whether carved in stone or calculated in equations, the message is the same. In the vastness, we cling to anchors real and symbolic to find our way. Perhaps the most humbling realization is that these mythic axes still shape our cosmic perspective today. When the James Webb Telescope peers toward the galactic center, or when neutrino detectors in Antarctica trace particles back to supermassive black holes, we're continuing a quest that began with shamans staring at the unmoving star. The tools have changed, but the awe remains because whether you call it Meru, Yggdrasil, or Sagittarius A, the impulse is identical: to find the still point in the turning world, and from there make sense of the infinite. Centuries before telescopes revealed the fiery hearts of stars, alchemists toiled in dimly lit workshops, convinced that metals could be perfected, that lead with the right catalyst might shimmer into gold. Their quest for the Philosopher's Stone, a substance said to grant eternal life and limitless transformation, seemed like pure mysticism. Yet hidden in their cryptic symbols and failed experiments was an astonishing intuition. The universe itself is a grand alchemical furnace where stars forge the elements of life in their cores. The alchemists weren't entirely wrong, they were just looking in the wrong direction. Instead of transmuting metals in crucibles, they should have been gazing upward, where supernova perform the ultimate act of cosmic alchemy. Consider the parallels. Just as alchemists believed in prima materia, a primal substance underlying all matter, modern astrophysics points to hydrogen, the first element born from the Big Bang's searing heat. In their quest to manipulate elemental properties, alchemists anticipated the periodic table's revelation that atoms are built from interchangeable parts. And when they wrote of the sun and moon as celestial counterparts to gold and silver, they unknowingly described stellar nucleosynthesis, where stars fuse hydrogen into helium, then helium into carbon, oxygen, and beyond, each step a rung on the cosmic ladder to heavier elements. The iconic Ouroboros, the serpent eating its tail that adorned alchemical texts, finds its mirror in the life cycle of stars, collapsing, exploding, and scattering their enriched remains to birth new generations. The real magic lies in how these ancient ideas anticipated stellar death as the universe's true philosopher's stone. When a massive star exhausts its nuclear fuel, it doesn't fade quietly. It detonates as a supernova, unleashing temperatures so extreme that atoms are ripped apart and reassembled. In those cataclysmic moments, iron nuclei capture neutrons to form gold, platinum, and uranium. Every ounce of gold in your jewelry was forged in such an explosion billions of years ago. The alchemist's dream of transmutation wasn't fantasy. It's the daily reality of cosmic chemistry, where neutron-star collisions literally, kilovonoas, scatter precious metals across galaxies like celestial Midas touches. What's poetic is how alchemy's language persists in astrophysics today. The metal-rich stars astronomers study aren't literal veins of gold, but stars seeded with elements heavier than hydrogen and helium, elements we now know are born in stellar crucibles. The alchemical symbol for the sun, a dot within a circle, inadvertently captured the process of proton-proton fusion, where hydrogen nuclei dots collide at the sun's core circle to create helium. Even the quest for an elixir of life finds resonance in how supernova debris, rich in carbon and oxygen, became the raw material for planets and, ultimately, life. This convergence reveals something profound. Humanity's drive to understand transformation transcends the boundary between magic and science. When an alchemist stirred a vial of mercury, trying to awaken its latent perfection, they were acting out a miniature version of what occurs in stars. The difference is scale, and the breathtaking truth that the stars themselves are the greatest alchemists of all, spinning hydrogen into the elements of everything, the calcium in your bones, the iron in your blood, the gold in your ring. The Philosopher's Stone wasn't a rock, it was a star, and its secret wasn't magic, it was the simple, sublime physics of light forging matter in the dark. The Hindu concept of Maya paints the world as a grand illusion, not a lie but a shimmering veil obscuring a deeper reality. Plato's prisoners in the cave mistake shadows for substance, just as we might mistake the solidity of our hands or the vastness of the sky for ultimate truth. These ancient ideas seemed like pure philosophy until quantum physics stumbled upon something astonishing. The universe might literally be a projection, a cosmic hologram where three-dimensional reality is encoded on a two-dimensional surface. The holographic principle, first proposed by physicist Gerard T. Hooft and later refined by Leonard Susskind, suggests that everything we experience, stars, galaxies, even our own thoughts, could be akin to a movie playing on the surface of a black hole's event horizon. Suddenly, those old myths about reality's illusory nature don't sound so metaphorical after all. Think of it like a credit card hologram tilted, and a flat sticker reveals unexpected depth. In the cosmic version, the sticker is the boundary of the observable universe, and the hologram is everything within it. The AD/S/CFT correspondence, a cornerstone of string theory, mathematically links events inside a theoretical universe to information painted on its outer shell. It's as if the Hindu goddess Maya, weaver of illusions, was whispering a clue about the universe's operating system all along. Even more striking, this aligns with indigenous Australian Dreamtime stories, where the physical world is a manifestation of songlines, invisible vibrational patterns that shape the land. Modern physics now suggests those songlines might be quantum entanglement, with particles instantaneously connected across vast distances as if part of a single, hidden design. The echoes grow louder when you examine ancient creation myths. The Egyptian god Thoth, scribe of the gods, records reality in a book that determines all events, a precursor to the holographic idea that information defines existence. The Buddhist sutras describe emptiness as the true nature of form, mirroring how holograms derive their solid appearance from interference patterns of light. Even the Gnostic belief in a flawed material world obscuring a purer realm finds eerie resonance in theories that our universe might be a low-resolution projection of a higher dimensional reality. These parallels aren't just poetic, they hint that human intuition has long sensed the universe's trickster nature. That solidity is a convincing performance, not the foundation. What's truly mind-bending is how holographic theory explains paradoxes that baffled physicists for decades. Black holes shouldn't be able to destroy information, yet anything crossing their event horizon seems lost forever. The holographic principle solves this by suggesting the information isn't destroyed. It's smeared across the horizon like cosmic graffiti, preserved in scrambled form. It's the myth of the phoenix reborn from ashes, rewritten in the language of quantum bits. Similarly, the hard problem of consciousness, how subjective experience arises from matter, might soften if the brain operates like a holographic decoder, translating quantum-level information into the rich tapestry of lived reality. Suddenly, the Maya concept of Leela, the divine play of creation, feels less like mysticism and more like a user manual for the universe's source code. Perhaps the most humbling thought is this: if the holographic principle holds, every ancient culture that spoke of reality as illusion was scientifically ahead of its time. When a Navajo sand painter creates a temporary artwork to heal, knowing its dissolution is part of its power, they're enacting the same truth physicists now chase, that impermanence and interdependence are woven into existence's fabric. Or when a Taoist sage observes that the 10,000 things rise and fall without cease, they're describing the quantum foam from which particles blink in and out of being. The myths got there first, not through equations, but through a profound attentiveness to reality's elusive heartbeat, the flicker behind the projection, the whisper beneath the noise. And that's the real magic. Whether through meditation or mathematics, we're all trying to peel back the same cosmic veil. Ancient Sanskrit texts describe Vimana's gleaming flying chariots that could traverse the heavens at unimaginable speeds, some said to be powered by mercury vortex engines or liquid sunlight. The Hindu epic Mahabharata recounts aerial battles between these craft, complete with weapons that sound unnervingly like modern descriptions of plasma beams. Half a world away, the biblical prophet Ezekiel witnessed a whirling wheel within a wheel descending from the sky, its metallic frames gleaming like burnished bronze, moving in any direction without turning. Fast forward to 1947, when pilot Kenneth Arnold coined the term flying saucer after seeing 9 crescent-shaped objects skipping like saucers across Washington's skies. The similarities aren't just curious, they're part of a pattern stretching back millennia, where humanity's visions of sky-bound vehicles blur the line between divine intervention and technological wonder. What's striking isn't just the consistency of these accounts, but the specificity. The ancient Indian text Samarangana Sutradhara details Vimana construction with meticulous precision. Strong and durable must the body be made, like a great flying bird of light material. With mercury underneath and iron heating apparatus, compare that to NASA's experimental ion thrusters, which use electric fields to accelerate charged particles for propulsion. The descriptions of Ezekiel's wheel, their rims full of eyes all around, mirror modern reports of UFOs studded with luminous panels or portholes. Even the Norse Valkyries, riding winged horses across the sky, find eerie counterparts in today's accounts of tic-tac-shaped craft darting above naval fleets. These parallels raise a tantalizing question. Are these stories pure myth, distorted memories of advanced ancient tech, or something even stranger, a shared human archetype anticipating future discoveries? The real magic lies in how these narratives evolve alongside our technological imagination. Medieval paintings of the Virgin Mary ascending to heaven on a flaming chariot give way to 19th-century airship scares, where newspapers reported mysterious dirigibles over American farmland decades before the Wright brothers' flight. The Hopi tribe's tales of the Blue Star Catchina, a celestial herald arriving in a flying shield, morph into 20th-century sightings of disc-shaped craft over New Mexico deserts. Even the Greek myth of Daedalus crafting wings from wax and feathers finds its modern echo in engineers designing biomimetic drones inspired by bird flight. It's as if humanity's collective unconscious has always been drafting blueprints for flight, long before physics caught up to fantasy. But here's where science adds a twist. While ancient astronaut theories suggest extraterrestrial visitations, another interpretation is even more profound. These stories reveal humanity's innate drive to conquer the skies. The Vimana texts don't just describe magic, they prescribe engineering principles, much like Leonardo da Vinci's helicopter sketches predated functional aircraft by centuries. The mercury engines mentioned in Sanskrit manuscripts could reflect early observations of static electricity or liquid metal properties, later formalized by science. Ezekiel's vision, analyzed by NASA engineer Joseph Blumrich, inspired a patented design for omnidirectional wheels. These myths weren't passive fantasies, they were active thought experiments pushing the boundaries of what seemed possible. Today, the legacy of these sky chariots lives on in our aerospace ambitions. Elon Musk's Starship and Jeff Bezos' Blue Origin rockets share more than a little DNA with the fiery ascents of mythic heroes. The International Space Station, with its rotating modules and solar wings, wouldn't look out of place in a Sumerian cylinder seal depicting gods in celestial boats. Even the search for UFOs, now rebranded as UAPs, unidentified aerial phenomena, by the Pentagon, continues humanity's ancient habit of scanning the skies for signs of the extraordinary. Whether these phenomena represent advanced craft, atmospheric oddities, or psychological projections matters less than the enduring truth they underscore. The dream of flight isn't just about technology. It's about transcendence, the longing to break earthly bonds and touch the realm of the gods, whether those gods are aliens, deities, or our own future selves. Perhaps that's why these stories resonate so deeply. They're not just about objects in the sky, but about the human spirit's refusal to be grounded. When the Wright brothers finally achieved sustained flight in 1903, they weren't just inventing a machine. They were fulfilling a prophecy as old as Icarus, as persistent as the Vimanas, as mysterious as Ezekiel's wheel. The chariots have changed, but the journey remains the same, upward, always upward into the waiting dark. 2,500 years ago, Pythagoras pressed his ear against the blacksmith's anvil and heard something extraordinary. The clang of hammers striking metal produced not just noise but mathematics. The intervals between pitches followed precise ratios, revealing hidden order in what seemed like chaos. From this epiphany, he spun a radical idea. The cosmos itself might be vibrating with a secret harmony, a music of the spheres too vast for human ears. Half a world away, Hindu sages chanted the sacred syllable, Om, believing it to be Nada Brahma, the primal sound from which all creation emerged. These two traditions, separated by continents and centuries, shared an intuition modern physics now echoes. The universe isn't silent. It sings, and the song might be written in the very fabric of reality. String theory, the controversial but dazzling framework of quantum physics, proposes that the smallest building blocks of matter aren't dots, but tiny, vibrating filaments like infinitesimal guitar strings. Each vibration produces a different note, manifesting as particles with unique properties. An electron might be one harmonic, a quark another, as if the universe were an unimaginably complex symphony. The parallels to ancient sound-based cosmologies are too striking to ignore. The Hindu Rigveda describes creation beginning with a cosmic hum, while the Aboriginal Dreamtime tells of ancestral spirits singing the world into existence. Even the biblical "Let there be light" implies vibration sound as the catalyst for form. These myths weren't just poetic flourishes, they were blueprints for a vibrational universe, glimpsed through intuition long before equations confirmed it. Dive deeper and the resonances grow richer. The Pythagorean concept of celestial harmony relied on precise mathematical relationships, much like string theory's requirement for 10 or 11 dimensions to maintain vibrational consistency. The ancient Chinese musical scale, based on the perfect fifth, mirrors the harmonic overtones that emerge from superstring equations. Even the Mayan belief in wind roads, invisible pathways carrying sound energy through the cosmos, finds a counterpart in modern theories about quantum foam, where space-time itself ripples with vibrational energy at the Planck scale. What's astonishing isn't just that these cultures imagined a musical universe, but how accurately their metaphors map to cutting-edge physics. When Tibetan monks chant to create mandalas of sand that dance into geometric patterns, they're demonstrating a truth science now quantifies: vibration shapes matter. The implications ripple outward. If strings are the universe's notes, then black holes might be cosmic bass drums, their event horizons ringing with gravitational waves when they collide, as LIGO observatories detected in 2015. The cosmic microwave background, that faint hiss from the Big Bang, could be the echo of the first chord struck at creation. Even dark matter, that elusive cosmic scaffold, might be the universe's undertone, a vibration too deep for our current instruments to hear. This isn't just metaphor, it's mathematics. String theory's equations describe resonance patterns that could explain why quarks pair the way they do, or why galaxies cluster along harmonic intervals in the cosmic web. Perhaps the most profound connection lies in how both traditions grapple with inaudibility. Pythagoras admitted the music of the spheres was imperceptible to mortals, just as string vibrations exist at scales a trillion times smaller than atoms. Hindu texts speak of anahata nada, the unstruck sound beyond physical vibration, a concept that mirrors the quantum vacuum, where particles flicker in and out of existence like notes in silent space. Both science and myth suggest that the deepest truths aren't heard with ears, but perceived through pattern, rhythm, and the mind's ear. So the next time you pluck a guitar string or feel thunder's rumble, remember, you're not just hearing sound. You're eavesdropping on the universe's oldest language, the same vibrational grammar that spun galaxies from emptiness and hums in every atom of your being. The ancients called it divine music, physicists call it quantum mechanics, but both are listening to the same cosmic symphony, and we're just beginning to discern the melody. Friedrich Nietzsche once posed a mind-bending thought experiment. What if every moment of your life, every joy and sorrow, was destined to repeat infinitely? His concept of eternal return wasn't just philosophical speculation. It was an uncanny echo of the Hindu belief in samsara, the endless cycle of death and rebirth where souls transmigrate through countless lives. These ideas might seem like abstract musings, but here's the astonishing part. Modern physics has stumbled onto something eerily similar. The multiverse theory suggests our universe might be just one bubble in an infinite cosmic foam, where every possible version of reality plays out simultaneously. Suddenly, those ancient visions of cyclical existence don't sound so metaphorical. They sound like prophetic glimpses into the quantum fabric of everything. Take the Hindu notion of kalpas, cosmic cycles where universes are born, dissolve, and reform like breath. Each cycle lasts 4.32 billion years, a number suspiciously close to the time it takes our solar system to orbit the Milky Way center. The Maya calculated their long count calendar in similar grand cycles, predicting renewal periods that align with galactic alignments we've only recently measured. These weren't random guesses, they were observations encoded as myth, hinting at a universe that resets itself. Now compare that to physicist Lee Smollen's controversial cosmic natural selection theory, which proposes that black holes might birth new universes with slightly tweaked physical laws, a literal Darwinian evolution of reality across infinite iterations. The parallels are too precise to dismiss. The real magic happens when you examine the details. Ancient Jain texts describe an infinite multiverse called Lokakasha, where realities stack like sheets of cloth, each with its own rules. The Norse Eddas speak of the 9 worlds connected by Yggdrasil, where different realms obey distinct logics, some frozen, some fiery, some beyond mortal comprehension. These descriptions mirror the bubble universes of inflationary cosmology, where separate domains might have different constants of physics, some with stronger gravity or faster light. Even the Buddhist concept of Indra's net, a cosmic web where each jewel reflects all others, finds a scientific counterpart in quantum entanglement, where particles instantaneously mirror each other's states across light years. What's truly humbling is how these myths anticipated the most radical implications of multiverse theory. The many worlds interpretation of quantum mechanics suggests every decision spawns branching timelines. You might have turned left in this universe, but somewhere your counterpart turned right. The Aztecs depicted this same idea in their 5 suns, each representing a world with different outcomes. The Aboriginal Dreamtime speaks of ancestors walking all possible paths simultaneously, a poetic parallel to Schrödinger's cat being alive and dead until observed. These cultures didn't have particle colliders, but they grasped a fundamental truth. Reality might be less a single story than an endless library of might-have-beens. So why does this convergence matter? Because it reveals something profound about human cognition. Faced with the vastness of existence, we've always sensed the patterns, whether through shamans divining alternate futures or physicists calculating wave function collapse. The multiverse isn't just a scientific hypothesis. It's the latest incarnation of humanity's oldest intuition. that every ending is a beginning, every choice unwinds infinite threads, and somewhere beyond the horizon of perception, all versions of us are living all possible lives. The equations may be new, but the wonder is ancient, written in the stars long before we knew how to read them. The story is chillingly familiar. A great flood swallows the land, sparing only a chosen few who escape by boat with Earth's creatures. You've heard it in Genesis as Noah's Ark, in the Hindu Shatapatha Brahmana as Manu's fish-guided ship, and in the Mesopotamian epic of Gilgamesh where Utnapishtim builds a cube-shaped vessel. Over 500 deluge myths span every inhabited continent, from the aboriginal rainbow serpent's rising waters to the Maya's hurricane sent by the god Huracan. What's astonishing isn't just the consistency of these stories, but how modern geology confirms their core truth. The Earth has known catastrophic floods before, and the warnings etched in myth are now echoed by climate science's dire projections. These ancient narratives weren't just allegories, they were survival manuals, passed down through generations like a planetary alarm bell. Consider the timing. When the last ice age ended roughly 12,000 years ago, melting glaciers triggered sea level rises of over 400 feet, enough to drown entire coastlines for centuries. The Persian Gulf, once a fertile river valley known as the Garden of Eden to some archaeologists, vanished beneath rising waters around 7,500 years ago. Similarly, the Black Sea flood hypothesis suggests a catastrophic breach around 5,600 BCE, when the Mediterranean burst through the Bosporus, submerging an area the size of Florida almost overnight. These events align uncannily with the timeline of early agricultural societies who would have witnessed and desperately remembered the water's relentless advance. The Aboriginal story of the Gulf of Carpentaria, once a vast freshwater plain now underwater, even describes saltwater killing freshwater plants, a detail too precise to dismiss as fantasy. What's even more striking are the shared motifs across cultures. The Babylonian Atrahasis epic speaks of the gods sending a flood because humanity's noise was unbearable, a poetic parallel to today's anthropogenic climate disruption. The Choctaw legend of the Great Canoe mirrors Noah's dimensions, while the Chinese tale of Nuwa patching the broken sky with colored stones hints at atmospheric repair. Even the details hold water. The Greek Deucalion's flood was preceded by unseasonal rains, just as modern climate models predict erratic precipitation patterns. These stories weren't just about water, they encoded observations about ecosystem collapse, refugee crises, and the fragility of civilization, themes we're grappling with today. Now fast forward to the present, where satellites map ice sheets crumbling into the sea and ancient methane bubbles erupt from thawing permafrost. The parallels between myth and modern science become uncomfortably clear. The same forces that shaped the flood legends, rising seas, shifting weather, displaced populations, are unfolding again, but this time with graphs and gigabytes instead of oral tradition. When the IPCC warns of coastal cities underwater by 2100, it's speaking the same language as the Welsh legend of Cantre Gwaelod, a drowned kingdom whose bells still ring beneath Cardigan Bay. The difference: we're not just witnesses to this deluge, we're the architects. Perhaps the most profound lesson lies in how these myths framed survival. Unlike modern doom-scrolling, ancient flood stories always ended with renewal. Noah's olive branch, Manu's repopulation of the earth, the Kayich Maya's new dawn after the waters receded. They balanced terror with hope, catastrophe with resilience. As Miami's streets flood during king tides and Venice's barriers strain against storm surges, we're relearning what our ancestors knew: that adaptation isn't just about arcs, but about rewriting our relationship with the natural world. The floods are coming, the myths told us so, but they also whispered something else, that after the waters, if we're wise, there's always dry land. From the shimmering Bifrost Bridge of Norse legend to the Aboriginal songlines that weave invisible pathways across the land, humanity's myths are filled with portals, magical thresholds where heroes step between worlds in the blink of an eye. The ancient Egyptians believed the pyramids were stargates for pharaohs to ascend to the heavens, while Hindu texts describe siddhis, enlightened beings who could fold space with their minds to traverse vast distances instantly. These stories might sound like pure fantasy, but buried within them is a startling scientific possibility that our ancestors were intuitively describing wormholes, the cosmic shortcuts predicted by Einstein's equations. According to general relativity, an Einstein-Rosen bridge is a theoretical tunnel through space-time, connecting two distant points like a celestial subway. Picture the universe as a sheet of paper folded, and a wormhole punches through the crease, turning a million light-year journey into a single step. The physics checks out. Massive objects like black holes warp spacetime so severely that they could, in theory, create these passageways. While no one's ever observed a natural wormhole, their mathematics eerily mirrors mythic descriptions of portals. Take the Rainbow Bridge, Bifrost said to burn with impossible colors to keep giants at bay. Modern simulations show traversable wormholes might radiate with intense energy at their mouths, creating a luminous, unstable threshold. The Mayan gateways carved into temple doorways, often depicting serpents swallowing the sun. Their undulating shapes resemble Penrose diagrams of black holes merging. Even the mechanics align. Aboriginal dreaming tracks describe pathways where ancestors walked, outside of time, crossing landscapes in moments, a poetic parallel to how wormholes could exploit space-time curvature to bypass conventional travel. The Greek oracle at Delphi, who inhaled vapors from a fissure to see distant futures, might have been channeling the time dilation effects near a wormhole's throat, where gravitational extremes warp clocks. And when Hindu yogis speak of the Akashic records, a cosmic library accessible through meditation, it's hard not to think of quantum entanglement, where information might theoretically traverse wormholes instantaneously. What's truly fascinating is how these myths anticipated the challenges of traversable wormholes. The Norse warned that Bifrost would shatter under the weight of armies during Ragnarok, just as physicists calculate that wormholes would likely collapse unless stabilized by exotic matter with negative energy. The Aztec god Quetzalcoatl descended through a smoking mirror portal that demanded ritual purity, perhaps intuiting the instability of space-time shortcuts. Even the Buddhist idea of the bardo, a transitional state between lives, mirrors the quantum foam fluctuations that might briefly birth wormholes before they vanish. Perhaps these stories endure because they tap into a deep human truth. The universe is far more connected than it appears. Whether through shamans' spirit journeys or astronauts' warp drive dreams, we've always sensed that distance is an illusion waiting to be unraveled. The stargates of legend may yet become the highways of tomorrow, not because myth was prophecy, but because humanity's oldest stories and science's newest equations are both reaching for the same impossible horizon. From the Vedic Ashvins riding their golden chariot across dawn's edge to the Roman twins Romulus and Remus suckled by a she-wolf, humanity's myths pulse with divine pairs, beings bound by blood yet balanced in opposition. These aren't just dramatic flourishes, they're cosmic reflections written in starlight. Look up at the constellation Gemini, the celestial twins Castor and Pollux, and you're seeing more than just two bright dots. You're witnessing a fundamental truth about the universe. Duality is woven into its fabric. Nearly half the stars in our galaxy aren't solitary suns like ours, they're binary systems, locked in an eternal dance where gravity choreographs their every move. The myths knew this long before telescopes proved it. Take the Ashvins, Hindu deities of morning and evening light, who heal the sick and guide lost travelers. Their myth mirrors the behavior of eclipsing binaries, pairs of stars that periodically dim as one passes in front of the other, a celestial rhythm that ancient skywatchers could track without knowing the mechanics. Or consider the Yoruba's Ibeji twins, spirits of harmony and chaos, whose interplay keeps the world in balance, not unlike how binary stars stabilize each other's orbits, preventing catastrophic collapse. Even the Chinese yin-yang symbol, with its swirling duality, finds a breathtaking counterpart in contact binaries like Alpha Centauri, where two stars orbit so closely they share atmospheres, blending into a single teardrop of light. What's astonishing is how precisely these myths map to astrophysical realities. The Navajo hero twins, Monster Slayer and Born for Water, traverse worlds to restore order, a narrative echoing how binary stars migrate through galaxies, scattering planets and asteroids in their wake. The Greek Dioscuri, Castor and Pollux alternate between the heavens and underworld, mirroring the zombie star phenomenon where one star in a pair dies, becoming a white dwarf that siphons material from its living sibling. These stories didn't just imagine stellar pairs, they encoded their life cycles. The real magic lies in how these celestial duos shape existence. Just as the Ashvin's chariot brings dawn, binary stars forge the elements that make life possible. When they finally collide, the resulting supernovas scatter gold, platinum, and uranium across the cosmos, precious metals birthed from stellar partnership. The Maoris Rangi and Papa, Sky Father and Earth Mother, locked in embrace until their children forced them apart, might as well be describing neutron star binaries spiraling toward merger, their final embrace rippling spacetime with gravitational waves. Perhaps this is why twin myths endure, because they remind us that even in the vast dark, nothing is truly alone. Whether in the embrace of gods or the gravity of stars, the universe thrives on connection. The next time you see Gemini shining overhead, remember, you're not just looking at stars, you're seeing the oldest love story ever told, written in fire and orbit. And it's still being told, one revolution at a time. Deep in the volcanic heart of Mount Olympus, the Greek god Hephaestus hammered divine weapons over an anvil of stars, his forge so hot it could shape fate itself. Half a world away, Hindu texts described Vishwakarma, the cosmic architect whose celestial workshop forged not just weapons, but entire universes from primordial fire. These mythic smiths didn't just craft objects, they embodied a universal truth about creation. That transformation demands unimaginable heat, pressure, and chaos. And nowhere is this more evident than in the cosmos's ultimate workshop, neutron stars, where nature itself becomes a blacksmith, bending matter into forms so extreme they defy imagination. Take the numbers first. A neutron star is what remains after a massive star goes supernova, collapsing under its own gravity until a teaspoon of its material weighs 1 billion tons. The heat at their cores reaches 1,000,000 degrees hotter than the blast furnaces of Hephaestus and Vishwakarma combined. Their magnetic fields are so strong, they could strip the iron from your blood from 1,000 miles away. Yet within this apocalyptic environment, something miraculous happens. These stellar corpses become factories for the universe's heaviest elements. Like mythic smiths hammering gold from base ore, neutron stars forge gold, platinum, and uranium in their violent mergers, scattering these precious metals across galaxies to one day become jewelry, electronics, even the fillings in your teeth. Parallels between divine forges and neutron stars go deeper than raw power. Hephaestus was said to work with cyclopes, assistants who imbued his creations with lightning. a poetic match for the relativistic jets neutron stars emit, beams of energy so intense they punch through interstellar gas like divine arrows. Vishwakarma's workshop floated on a sea of creativity, mirroring how neutron stars often orbit in binary systems, drawing material from companion stars to fuel their cosmic alchemy. Even the myth's emphasis on imperfection resonates. Hephaestus was lame, Vishwakarma's design sometimes flawed, just as neutron stars glitch, suddenly spinning faster when their crusts crack under immense pressure. But the real magic lies in what these stories reveal about human intuition. Long before telescopes, cultures sensed that creation isn't gentle. The Norse dwarves Brokkr and Eitri had to withstand the roar of bellows so loud they thought their hearts would burst, just as neutron stars form in supernova loud enough to outshine entire galaxies for weeks. The Japanese god Amatsumara stoked his forge with breath that could melt stone, foreshadowing the neutrino bursts from neutron star collisions, where a single teaspoon of this ghostly particle flow could level mountains. These myths weren't just about gods, they were about recognizing that the universe's most profound acts of making require unmaking first. What's truly humbling is realizing neutron stars might have inspired these legends. Some researchers speculate that ancient skywatchers witnessed the Crab Nebula's formation in 1054 AD, a supernova so bright it was visible by day for weeks. Could the tales of celestial smiths hammering in the heavens have sprung from observing such violent stellar rebirths? When the Maori speak of Tohaki climbing the sky to retrieve the baskets of knowledge amid fiery torrents, were they describing the gamma-ray bursts that accompany neutron star mergers? We'll never know for certain, but the overlap is haunting. Today, the legacy of these cosmic forges surrounds us. The gold in your wedding ring, the uranium powering reactors, even the iodine in your thyroid, all were likely forged in neutron star collisions billions of years ago. Every time you hold something heavy and precious, you're touching the aftermath of a celestial workshop far beyond Hephaestus' wildest dreams. The myths got it right, creation isn't tidy. It's born in fire, shaped by violence, and delivered across the cosmos like a blacksmith's masterpiece, waiting for beings like us to stumble upon it and wonder. 25 million years before humans walked the earth, monstrous beasts ruled the land, creatures so colossal their bones still surface today, bleached white by time. Imagine a shepherd in ancient Greece stumbling upon a skull the size of a wine barrel, with a single massive eye socket staring blankly from the earth. What else could it be but proof of the Cyclops, or Chinese villagers unearthing serpentine vertebrae longer than a fishing boat, instantly recognizing the bones of dragons? These weren't just flights of fancy, they were humanity's first paleontology reports, written in the language of myth. Take the griffin, that iconic eagle-lion hybrid guarding golden hordes in Scythian tales. For centuries, scholars dismissed it as pure imagination, until fossil hunters uncovered Protoceratops skeletons in Mongolia's Gobi Desert. These beaked dinosaurs lay exactly where ancient nomads said griffins nested, their bony frills resembling wings when half buried in sand. Even their gold-hoarding behavior makes sense. Protoceratops fossils often appear near gold deposits, their bones bleached pale yellow by minerals. The griffin wasn't invented, it was reconstructed from fragments, a prehistoric jigsaw puzzle assembled by storytellers. Then there's the thunderbird, a winged titan from indigenous North American lore said to create storms with its wings. The legend spans from the Pacific Northwest to the Great Lakes, always describing a creature large enough to carry whales in its talons. Now examine the fossil record. 12,000-year-old condor bones found in California show wingspans over 16 feet, twice the size of any living bird. Even more telling, many Thunderbird stories cluster around the Labria tar pits, where dire wolves and saber-tooths once struggled in sticky death traps. Is it coincidence that these tales emerge where Pleistocene megafauna fossils lie thickest? The real magic lies in how these myths preserved ecological memory. The Maori Taniwha, dragon-like river guardians, often match descriptions of extinct New Zealand crocodilians. Aboriginal stories of the bunyip, a swamp-dwelling monster, align perfectly with diprotodon fossils, a hippo-sized marsupial that vanished 40,000 years ago. Even the Bible's behemoth, described as a creature that moves its tail like a cedar, makes startling sense when you consider prehistoric elephant relatives like Danathurium, whose tails could indeed resemble tree trunks. These stories weren't just entertainment, they were oral fossil records passed down across generations long before museums existed. What's truly breathtaking is how these legends anticipated scientific discoveries. When medieval Europeans unearthed woolly rhinoceros skulls with hooked nasal bones, they called them unicorn remains, not realizing Ice Age rhinos once roamed their homelands. The Chinese dragon's antler-like horns mirror the ossicones of giant giraffids like Civathurium, while cyclopean skulls, now recognized as dwarf elephant fossils, still dot Mediterranean islands where the one-eyed giant myth flourished. These creatures didn't vanish completely, they shape-shifted into story, waiting for science to decode their true forms. So the next time you hear an old tale about giants or fire-breathing serpents, don't dismiss it as fantasy. Instead, listen closely, because woven into those myths might just be the distant echo of a predator's roar, or the tremor of footsteps from a world long gone but not forgotten. The dragons never died, they just became stories sleeping in the earth until we were ready to dig them up again. Before light, before matter, before time itself, there was the void. The Babylonians called it Tiamat, a roiling abyss of saltwater chaos where nothing took form. The Greeks named it chaos, a yawning chasm so empty even the gods feared its hunger. These weren't just poetic flourishes, they were humanity's first attempts to personify the unimaginable, pure, unfathomable nothingness. Fast forward to 2023, when astronomers pointed telescopes toward the Boötes void, a spherical region of space 300 million light-years wide containing just 60 galaxies, a cosmic desert so vast you could fly through it for eternity and never touch a star. The parallels aren't just striking, they're evidence that myth and science share the same primal awe in the face of emptiness. What's astonishing is how precisely these ancient stories mapped the structure of cosmic voids. Tiamat wasn't just formless water, she was described as a serpentine force encircling creation, her coils defining the boundaries between realms. Modern simulations reveal galaxy filaments curl around voids in eerily similar serpentine patterns, their gravitational walls sculpted by dark energies push against matter. The Mayan underworld Xibalba, a place of fright where gods tested souls in featureless darkness, mirrors the way voids distort space-time itself, stretching light into spectral echoes as it traverses their emptiness. Even the Aboriginal concept of Altura, a dreamtime void preceding existence, aligns with cosmology's dark ages, that silent epoch before the first stars flickered to life. But why did cultures worldwide feel compelled to personify nothingness? Perhaps because the human mind recoils from true emptiness. Neuroscience shows our brains fill gaps in perception. We see faces in clouds, hear whispers in static. The Egyptian nun, that primordial watery abyss, wasn't inert. It seethed with potential, much like quantum foam's virtual particles flicker in and out of vacuum. The Norse Ginnungagap, the yawning void between fire and ice realms, was said to hum with latent energy, a poetic premonition of the cosmic microwave background's faint hiss, the afterglow of creation still resonating in every direction. These myths didn't just describe absence, they infused it with possibility, sensing that voids aren't passive but active architects of cosmic structure. Nowhere is this clearer than in the Great Nothing, stretching 1.8 billion light-years near the constellation Eridanus. This void defies expectations, its emptiness so extreme that some theorize it might be a bruise from a collision with another universe. Compare that to the Maori's Tikor, the void without end, where Io, the supreme being, whispered creation into being. Both describe a nothingness so profound it becomes generative, just as quantum fluctuations in vacuum energy may have sparked the Big Bang itself. The Hindu Rigveda puts it starkly: non-being existed, being did not. Modern equations say the same. From zero-point energy to false vacuum decay, physics confirms that nothingness is never truly still. The real magic lies in how these voids shape everything. Like negative space in a painting, cosmic voids define the universe's structure by what isn't there. Galaxy clusters huddle along their edges like campfires in a vast, dark plain. The Boötes void's gravitational pull subtly warps the trajectories of distant stars, while its emptiness cools light passing through, stretching photons into redder wavelengths, a literal darkening of the cosmos. It's no wonder the Aztecs depicted Tlaltecutli, the Earth monster, as a gaping maw that both consumed and birthed worlds. Voids aren't just holes, they're cosmic lungs, inhaling galaxies in one epoch and exhaling them transformed in another. Perhaps this is why the abyss haunts our stories. Whether it's Lovecraft's eldritch horrors lurking in the interstellar dark or the Buddhist concept of sunyata, emptiness, as the fundamental nature of reality, we keep circling back to the void. Not as an ending, but as a beginning, because every time science peers deeper into the cosmic nothing, we find the same truth our ancestors intuited. In the grand tapestry of existence, the empty spaces hold everything together. The darkness isn't broken by the light, it's what makes the light visible at all. From the snow-capped peak of Mount Olympus, where Zeus hurled thunderbolts, to the floating summit of Mount Meru, said to pierce through 7 celestial realms, humanity has always reserved its highest ground for the divine. These sacred mountains weren't just landmarks, they were stairways to the gods, places where heaven and earth touched. And now, as our telescopes and rovers map the rust-colored plains of Mars, we've found a startling continuation of this ancient tradition. Olympus Mons, a shield volcano so massive it dwarfs Everest 3 times over. Rising 16 miles into the thin Martian sky with a base the size of Arizona, this isn't just a geological wonder, it's a cosmic echo of our oldest mythic heights, proving that the urge to sanctify mountains transcends not just cultures but planets. Consider the uncanny similarities between Olympus Mons and its earthly counterparts. Like Mount Kailash in Tibet, revered by Hindus, Buddhists, and Jains as the axis of the universe, Olympus Mons stands nearly perfectly aligned with Mars' rotational axis, a literal planetary pivot. The Hawaiian goddess Peel's volcanic home, Kilauea, shares the same gently sloping profile as Olympus Mons, both formed by successive lava flows. Even the biblical Mount Sinai, where Moses received the commandments amid smoke and tremors, mirrors the volcanic origins of our Martian giant. These parallels aren't coincidental, they reveal how geology and sacred geography intertwine. When ancient people witnessed mountains spewing fire or disappearing into clouds, they saw the fingerprints of the divine, and Olympus Mons, with its caldera complex like a series of celestial chambers, would have left them awestruck. What's truly mesmerizing is how these mountains function as cosmic bridges. In Andean cosmology, peaks like Orsungate were considered Apu's living spirits that channeled energy between Pachamama Earth and Honan Pacha, the upper world. Olympus Mons, with its height piercing through 85% of Mars' atmosphere, literally connects the planet's surface to the edge of space. The Zoroastrians revered Mount Hara as the first creation, around which the stars revolved, an idea that finds eerie resonance in how Olympus Mons' sheer bulk influences Martian weather patterns, its summit generating ice clouds that swirl like celestial veils. Whether carved by faith or physics, these peaks serve the same purpose, thresholds between realms. Nowhere is this connection more striking than in the mountain's very name. When Italian astronomer Giovanni Schiaparelli dubbed it Olympus Mons in 1879, he wasn't just making a poetic comparison, he was unconsciously continuing a tradition that began when the Greeks first called their highest peak Olympus, meaning the luminous one. The Maya named their sacred volcanoes Huitzhab, or sleeping giants, while the Japanese worship Mount Fuji as the dwelling of the fire goddess Konohana Haim. Across epochs and civilizations, we've projected our yearning for the transcendent onto these geological titans. And now, with Olympus Mons, we've done it interplanetary, proving that the need to find the sacred in the stratospheric is written into our DNA. But here's the most humbling thought. Olympus Mons may not be done shaping stories. Active lava flows might still creep beneath its surface, and future colonists gazing up at its distant summit will inevitably weave new myths. Perhaps they'll speak of the day when humans first climbed its flanks, or whisper of spirits in its mist-shrouded caldera, because whether on Earth or Mars, mountains will always be more than rock and ice. They're the places where we reach for the infinite, one step at a time. And as Olympus Mons reminds us, that reach now extends far beyond our pale blue dot, into the rust-red skies of worlds we're only beginning to know. On July 4, 1054, a star in the constellation Taurus blazed so brightly it outshone Venus, visible even at midday for 23 days. Chinese astronomers called it a guest star, meticulously recording its position near the moon's crescent. Halfway across the world, ancestral pueblones painted its sudden brilliance on canyon walls, while Japanese courtiers interpreted it as an omen of political upheaval. What they witnessed was no ordinary star, but the violent death throes of a massive sun, a supernova now known as the Crab Nebula. This cosmic catastrophe became a cultural touchstone, woven into myth and memory across continents. Yet buried beneath these ancient star charts lies something even more profound: humanity's first attempts to document stellar evolution, written in the language of celestial prophecy. The Crab Nebula's supernova wasn't an isolated event. Over 2 millennia earlier, Babylonian astrologers etched cuneiform tablets describing stars that flared like torches, correlating their appearances with droughts and dynastic changes. The Roman historian Pliny the Elder wrote of a comet so radiant it split the night like daylight, possibly referencing the supernova that birthed the Vela remnant around 8000 BC. These accounts reveal a pattern. Every civilization that witnessed a supernova transformed it into narrative, sometimes as divine messengers, other times as harbingers of doom. The Aboriginal Wardaman people of Australia still sing of a fire star that brought both destruction and renewal, echoing modern astronomy's understanding that supernovas seed galaxies with the heavy elements necessary for life. What's astonishing is how accurately these myths captured supernovas' astrophysical reality. The Hindu scripture Surya Siddhanta describes stars exploding with light that nourishes new worlds, foreshadowing the discovery that supernovae forge carbon, oxygen, and iron in their furnaces. The Norse myth of the wolf skull devouring the sun mirrors the process of a white dwarf star consuming material from a companion until it detonates as a Type Ia supernova. Even the biblical Star of Bethlehem, if it was a supernova as some theorize, aligns with the timing of a known stellar explosion recorded by Chinese astronomers in 5 BC. These stories weren't just symbolic, they were observational science in narrative form, preserving celestial mechanics across generations. The real turning point came when telescopes turned mythology into mathematics. In 1758, astronomer John Bevis discovered the Crab Nebula's wispy remnants, though it would take another 2 centuries to connect it to the guest star of 1054. When Tycho Brahe observed a supernova in 1572, his precise measurements shattered the Aristotelian notion of an unchanging heavens, proving stars could die spectacularly. Today, the Chandra X-ray Observatory reveals the Crab's pulsar spinning 30 times per second, its magnetic fields accelerating particles to near light speed. The same explosion, once seen as an imperial omen, now teaches us about neutron stars and cosmic rays. Yet the most poetic convergence lies in how these stellar ghosts still shape culture. The Japanese word shinrabancho, a meaning all things in nature, originally described the 1054 supernova's fleeting omnipresence. Now it symbolizes universal interconnectedness, much like how supernova debris links all life through shared stardust. The Navajo phrase "Shineon" captures both the explosive death of stars and the birth of new patterns, mirroring astrophysics' revelation that destruction and creation are 2 sides of the same cosmic coin. So the next time you gaze at the Crab Nebula's tangled filaments through a telescope, remember, you're not just seeing a stellar corpse, you're witnessing humanity's oldest dialogue with the cosmos, where omens become equations, and the fire that once foretold emperors' fates now illuminates the life cycles of galaxies. The stars may not speak in words, but their light carries stories written long before we knew how to listen. Long before the first atomic clocks hummed in temperature-controlled laboratories, time was measured in shadows and water drops. The Egyptian god Thoth, depicted with the head of an ibis, wasn't just the scribe of the gods. He was said to have invented the sundial, dividing the day into measurable hours as his sacred birds shadow-traced arcs across temple courtyards. Half a world away, the Chinese legend of Zhi told of a charioteer who drove the sun across the sky, her journey marked by the steady drip of water clocks in imperial observatories. These myths weren't just stories, they were humanity's first attempts to wrestle time into submission, to impose order on the relentless, invisible flow that governed everything from harvests to empires. Fast forward to today, where timekeeping has shifted from celestial mechanics to quantum vibrations. In the basement of the U.S. Naval Observatory, a cesium atomic clock counts time not by the sun's movement, but by the hyperfine transition of electrons, a process so precise it would take 100 million years to lose a single second. Yet beneath this staggering technological leap lies the same primal urge that inspired Thoth and Zhi, the need to anchor ourselves in time's river. The ancient Babylonians divided the day into 24 hours based on their sexagesimal number system, a convention we still use today. Their zodiacal timekeeping, which linked hours to constellations, finds an unexpected parallel in modern atomic clocks, which rely on the consistent behavior of atoms, a cosmic clockwork far more reliable than the stars. What's astonishing isn't just the contrast between these methods, but their shared philosophy. The Hindu concept of Kala, time as both destroyer and creator, mirrors the dual role of atomic clocks in Einstein's relativity, where precise timekeeping reveals that time itself bends and warps under gravity. The Mayan long count calendar, which measured epochs in cycles of 144,000 days, wasn't so different from today's leap seconds, those occasional adjustments that keep atomic time in sync with Earth's slowing rotation. Even the Norse myth of the wolf skull chasing the sun, threatening to devour it and plunge the world into chaos, resonates with modern anxieties about timekeeping failures. Imagine GPS satellites falling out of sync, their navigation errors compounding with every uncorrected nanosecond. The real magic lies in how these ancient timekeeping myths anticipated modern challenges. The water clocks of ancient Greece, called clepsydras, had to account for seasonal changes in water pressure, a problem akin to compensating for relativistic effects on satellites. The Inca's Intihuatana, or hitching post of the sun, functioned as both calendar and spiritual anchor, much like how atomic clocks now underpin global finance, telecommunications, and space exploration. When the medieval Benedictine monks divided their days into canonical hours of prayer, they were effectively running a medieval version of network synchronization, aligning human activity across continents using the sun as their atomic oscillator. Perhaps the most poetic convergence is how both myth and science grapple with time's elusiveness. The Dreamtime stories of indigenous Australians describe a timeless realm where past, present, and future coexist, a concept that wouldn't feel out of place in a quantum physics lecture on the block universe theory. The Aztecs' Xupohualli, a 260-day calendar interwoven with their 584-day Venus cycle, reveals the same obsession with celestial patterns that drives today's search for ever more stable atomic transitions, like the strontium lattice clocks now pushing precision to 1 second in 15 billion years. So the next time you check your smartphone's atomic sync time, remember, you're participating in a tradition that stretches back to shadow-watching priests and star-mapping astronomers. The units have changed from sundial marks to cesium oscillations, but the quest remains the same: to pin down the most elusive dimension of all, to hear the universe's heartbeat and finally say, "We measured this." And that's the real wonder, whether carved in stone or coded in quantum states. Humanity's timekeeping journey is at its core the story of our refusal to let the infinite slip through our fingers unnoticed. Atlas, the Titan condemned to shoulder the heavens for eternity, wasn't just holding up the sky, he was embodying humanity's oldest cosmic anxiety. What keeps the universe from collapsing? Cultures worldwide spun tales of divine sustainers. The Hindu serpent Ananta floating in the cosmic ocean, supporting Vishnu as he dreams worlds into being. The Iroquois great turtle, whose shell forms the foundation of Turtle Island. Even the Egyptian god Shu, standing between earth and sky to prevent their catastrophic reunion. These weren't just colorful origin stories, they were intuitive grasps at a truth science has only recently quantified. Dark energy, that mysterious force accelerating the universe's expansion, plays the same role as these mythic titans, not by holding things together, but by relentlessly pushing them apart. The parallels between these cosmic guardians and dark energy's behavior are eerily precise. Take Ananta, whose endless coils symbolize infinite time and space, a striking metaphor for how dark energy stretches the very fabric of the cosmos, creating more emptiness as it goes. Or consider the Mayan Bacabs, 4 deities who stood at the cardinal directions holding up the sky. Modern cosmology reveals a similar scaffolding. Dark energy's repulsive force operates uniformly in all directions, its pressure counteracting gravity's pull like invisible pillars preventing cosmic collapse. Even the Norse Ymir, whose dismembered body became the universe's structure, finds a dark counterpart in the Lambda-Cedium model, where dark energy's influence emerges from the vacuum of space itself, a kind of cosmic body holding reality together through its absence. What's truly fascinating is how these myths anticipated dark energy's paradoxical nature. The Turtle Island legend describes a world that grows as the turtle swims, mirroring how dark energy causes space itself to expand, carrying galaxies along like debris on a widening river. The Greek Atlas, straining under his burden, embodies the tension between gravity and dark energy, one pulling inward while the other pushes outward. Even the Buddhist concept of akasa, an all-pervading space that allows for movement and change, resonates with dark energy's role in creating the cosmic arena where galaxies evolve. These stories didn't just imagine sustainers, they intuited the dynamic balance that keeps existence from either crumbling or clumping into oblivion. Now here's where the analogy deepens. Many mythic sustainers aren't static, they're active participants in cosmic cycles. The Aztec's fifth sun is upheld by sacrificial energy, requiring constant renewal. Similarly, dark energy isn't a fixed force. Its density appears constant as space expands, meaning more space creates more repulsive push, a self-perpetuating cycle eerily reminiscent of sacrificial cosmology. The Babylonian Tiamat, whose divided body forms the heavens and earth, finds a scientific echo in theories suggesting dark energy's strength may have emerged from primordial symmetry breaking, where a unified force split to create the universe's structure. Perhaps the most humbling realization is that dark energy, like the deities of old, remains profoundly mysterious. We can measure its effects, the way supernova recede faster than expected, the cosmic microwave background's subtle fingerprints, but its true nature eludes us. In this way, it's the perfect modern myth, an invisible, omnipresent force shaping reality, just as Atlas shaped the ancient sky. The difference, instead of a titan's muscles, we have equations. Instead of storytelling, we have supercomputers, but the awe remains the same because whether through myth or mathematics, we're still asking the same question: what holds it all up? And the answer, it seems, is as elusive as ever. Imagine a child born on Mars, gazing up at Earth not as a home, but as a pale blue star in their alien sky. What stories will they tell about it? Will Earth become their mythic lost homeland, their Atlantis or Avalon floating in the darkness? This is the next frontier of cosmic storytelling, not just interpreting ancient patterns, but inventing new ones as we step into the universe ourselves. Every major discovery rewrites humanity's narrative. When Galileo's telescope revealed Jupiter's moons, it shattered the old geocentric myths. When Hubble showed galaxies racing apart, it birthed tales of the Big Bang. Now, as we stand on the brink of finding biosignatures on exoplanets or decoding the whispers of gravitational waves, we're priming the pump for myths we can't yet imagine. Take the TRAPPIST-1 system with its 7 Earth-sized worlds orbiting a cool red dwarf. To astronomers, it's a data set: orbital periods, atmospheric spectra, potential habitable zones. But to future storytellers, it might become the 7 Sisters reborn, a celestial family bound by tidal forces instead of blood. Or consider Oumuamua, that mysterious interstellar visitor shaped like a cosmic cigar. Scientists debate whether it's a nitrogen iceberg or a hydrogen snowball, but poets and world builders have already spun it into tales: a derelict generation ship, a celestial seed pod, a shard of some shattered alien world. The facts matter, but the stories we wrap around them matter just as much. Artificial intelligence is already drafting its own cosmic narratives. When Google's DeepMind mapped protein folding, it didn't just solve puzzles, it revealed hidden architectures of life itself. Future AI cosmologists might detect patterns in galaxy formation that suggest entirely new creation myths, or uncover quantum phenomena that rewrite our understanding of time. Imagine an AI trained on every myth ever told, suddenly recognizing a gravitational wave signature that matches the Hindu concept of the universe's cyclic breathing. Would that be science or poetry? The line is blurring. Then there's the human element the stories will carry with us as we become an interstellar species. The first crewed mission to Mars won't just bring scientists and engineers, it'll bring myth makers. When those astronauts experience the overview effect while seeing Earth from Martian orbit, when they stumble upon the first unmistakable fossil in Valles Marineris, when they celebrate the first off-world birth, these moments will crystallize into new legends. The red dust that clings to their boots might become sacred, like the soil of I's grand shrine or the Ganges banks. The first Martian sunset witnessed through a habitat window could inspire rituals lasting millennia. Quantum physics is brewing its own mythology. The many worlds interpretation already feels like something from the Eddas, a cosmic tree with infinite branches where every possibility plays out. As we probe deeper into quantum gravity and holographic universes, we might find that the old shamans weren't entirely wrong about reality's dreamlike nature. Perhaps the Aboriginal songlines, those invisible pathways connecting landmarks across vast distances, will find their parallel in quantum entanglement, where particles communicate instantly across light years. The real magic lies in how these future stories will loop back to the old ones. When we finally meet extraterrestrial intelligence, their myths might share uncanny similarities with ours: flood stories from water worlds, fire myths from volcanic planets, creation tales that all point to some universal truth about how consciousness perceives the cosmos. Or perhaps their narratives will be so alien that they force us to reinvent storytelling itself. Either way, one thing's certain: as long as humans, or post-humans, gaze upward, we'll keep weaving the universe into meaning. The night sky was our first storybook, and it's far from finished. From the flickering shadows of Paleolithic cave fires to the glowing screens displaying James Webb's deepest field images, one thread connects us across the millennia: the irresistible urge to narrate the cosmos. Those early storytellers tracing star patterns on rock walls weren't just entertaining, they were pioneering scientists, observing celestial rhythms and encoding them in stories durable enough to outlast empires. Consider the Aboriginal elders who have passed down oral star maps for over 40,000 years, their songlines preserving precise astronomical knowledge through melody and myth. Or the Babylonian priests who etched Venus's 8-year cycle onto clay tablets alongside prayers to Ishtar, blending meticulous observation with sacred meaning. This wasn't primitive guesswork, it was data collection disguised as divinity, the first attempts to transform cosmic chaos into comprehensible patterns. What's breathtaking is realizing how many scientific truths were hiding in plain sight within these ancient narratives. When Polynesian navigators spoke of Tilopa, flashing underwater lightning that guided canoes to distant islands, modern oceanography revealed they were tracking bioluminescent plankton blooms triggered by deep-sea currents. The Dogon's detailed knowledge of Sirius B, a star invisible to the naked eye, mirrors astronomers' charts with unsettling accuracy. Even the Greek myth of Persephone's cyclical descent into the underworld, once dismissed as mere allegory, now reads like an intuitive grasp of seasonal darkness, anticipating Earth's axial tilt before geometry could prove it. These stories weren't failures of logic, they were frameworks, scaffolding for truths waiting to be measured. Today's scientists are inheritors of this tradition, whether they realize it or not. When astrophysicists speak of black holes singing in gravitational waves or describe the cosmic web as the skeleton of the universe, they're engaging in the same mythic impulse that saw thunder as Thor's hammer or comets as celestial serpents. The language has changed, but the purpose remains: to make the unfathomable familiar. Take dark matter. that invisible cosmic glue described by one researcher as the modern ether, hearkening back to the ancient concept of the fifth element pervading all things. Or quantum entanglement, often called spooky action at a distance, in a nod to the supernatural. Science hasn't eliminated the need for poetry. It's given us new metaphors to channel the same awe. As we stand at the edge of tomorrow's discoveries, perhaps detecting biosignatures on exoplanets or unraveling dark energy secrets, we do well to remember this lineage. The Navajo, changing woman who embodies cosmic renewal, might hold insights for theories of cyclical universes. The Hindu god Shiva's dance of destruction and creation could inspire new models of quantum vacuum fluctuations. These aren't relics to discard, but lenses to re-examine, proving that the best science retains a spark of the mythic, that moment when hard data meets the human hunger for meaning. So let's keep telling stories about the stars, whether through equations or epic poems, because when the next revolutionary discovery shakes astronomy, when we finally hear an alien broadcast or photograph a wormhole, we'll instinctively reach for narratives to contain it. Not to diminish its truth, but to deepen our connection to the cosmos we're forever trying to understand. The universe whispers in wavelengths and wonders, and we're still learning how to listen.